Guten Tag, good day. Welcome to Container Days 2022. And welcome to this virtual workshop where we'll give you the opportunity to explore two related cloud-native infrastructure technologies. My name is Jim Barton, and I'm a field engineer with Solo.io in the US. In the first of these two sessions, you'll explore Glue Edge, a cloud-native API gateway based on Envoy proxy. Glue Edge is a rock-solid gateway that's been hardened through multiple enterprise customer deployments over the past 3 years. In the second session, we'll take a look at one of the newest extensions to the Glue Edge gateway, and that is its GraphQL support built directly into the Envoy proxy. In other words, with Glue GraphQL, you can now deploy GraphQL APIs by leveraging your existing API contracts and without spinning up a separate dedicated GraphQL server. Those are huge wins from a developer and an operational standpoint. Both of these segments for core Glue Edge and its GraphQL extension will be presented using Instruct as the workshop platform. That means so long as you have a modern web browser and a solid internet connection, then you'll be able to follow along with this exercise in your own sandboxed environment. Watch for the Instruct links to appear at the appropriate time during the upcoming workshop presentations. So we thank you for joining us today. Let's get started by digging into the Glue Edge API Gateway. This is a workshop on cloud native API gateways with Glue Edge. I know for a fact how valuable your time all is, and so I really appreciate you all carving out a couple of hours, 2.5 hours on a Thursday afternoon to join us and learn more about this. So we will do our best to make this time valuable for you. My name is Jim Barton. I am a field engineer with Solo.io. I have been here for 2 years now. Before that, I spent the previous decade architecting, building, operating enterprise scale systems at Red Hat and Amazon before that. So we're really happy to have you here. And I also want to introduce Jason Shupik. Jason, tell us a bit about yourself.
Hey everyone. I also have a bit of a storied past. I'm recently here to Solo. I'm a field engineer. Previous to Solo, I was a field engineer at Rancher Labs. And then previous to that, I was also a Red Hat consulting for OpenShift.
Yeah.
So I'm pretty well versed in the distributed systems API ecosystem.
Yeah, well, one of the things you'll learn when you work with Solo is we do run something of a Red Hat refugee camp here. So not really, but we do have a lot of former Red Hatters. So thank you, Jason. So Jason is going to be doing our technical support today. He's going to be monitoring the chat channel and answering your questions. I'll also take a look at the chat stream occasionally, and we'll ask questions. We don't have a huge audience here today, so we should be able to address your questions as we go through this. So thank you, Jason, for being here. This is a Glue Edge workshop. Glue Edge is an API native gateway, a cloud native API gateway. We'll talk about what that means a little more in just a second. I want to start out and let you know a little bit about what this workshop is. So this is very much an interactive, hands-on workshop. We feel like this is a product that typically comes to life in the hands of engineers. And when engineers want to learn about something, the best way to do that is in a hands-on fashion. And so we've done our best to create a workshop environment where you'll actually get that experience. So what you're going to be doing today, we're using a product called Instruct, which is a really excellent vehicle for doing these kinds of hands-on exercises. So every one of you will have your own computing environment provisioned with a K3s cluster on it and some other associated tools. And we'll actually walk through these exercises together. I kind of view my role here as more of a tour guide. So we will go through. We'll talk a little bit about kind of what motivates this workshop and the product offering. But then we will spend the vast majority of our time actually in a hands-on working session where we'll go through. We'll configure the gateway. We will do some basic traffic management exercises to show you how that works. We will do a variety of security exercises. We'll talk about TLS. We will talk about OIDC. We will talk about Open Policy Agent for authorization. We'll talk about what else will we talk about? We'll talk about WAF for web application security. We will talk about observability in a GluEdge context. And so hopefully at the end of this period, you will have a good working knowledge of what GluEdge is and be ready to hopefully try it out in your environments. Okay, so let's go ahead and get started. The way I want to get started, so there is a little bit of a spin up time in the exercises. And so what I want to do, if you would like to follow along, so you don't have to follow hands-on. I'm going to be doing everything here on my screen. You'll be able to see that. So if you prefer to just watch and listen and learn that way, that's absolutely perfectly fine. But if you're like me and you're more of a hands-on person, what we're going to do is I'm going to go ahead and give you a link now that will let you spin up your Instruct your Instruct environment. And it takes that a couple of minutes to build and provision the clusters and so forth. So let me give you. I'm going to drop a link in the chat right here. Okay, you should see a link in the chat right now. So I encourage you to click through that link. In fact, I'll do the same thing here in my environment. And so what that's going to do, if you've never signed up for Instruct before, you may have to go through a little bit of an exercise there. Shouldn't take you more than a few seconds, hopefully. And eventually you'll get to a point like this when you click through that link that basically represents your invitation to this workshop. You'll see a screen like this one. And so if you go ahead and you add this workshop to your study room, then you'll get a message like this that the content has been added. And so we can click through this My Exclusives button, and you can see I obviously have done a lot of things on Instruct over time, but you can see right here you should have at least one called GluEdge Workshop. And so go in here and view this track, and that should take you to an interface like this. Okay. When you get to this interface, go ahead and click on the Start Track button. All right. And so when we start track, you should see the little GluEdge Enterprise logo here. You should also see something that says, hey, we're creating your environment right now, and this is going to take a couple of minutes. So if you can give me a thumbs up or a +1 or something just to indicate that you're on track to having this happen, that'll be good. Just drop that in the chat. If you have any issues, feel free to put that in there as well. And Jason will help you through any issues. Okay, good. All right, so far so good. So let's go back here. While we're waiting for that to spin up, should just take a minute. Let me just walk through a little bit about GluEdge and kind of what motivates it and why we've made some of the architectural choices we have at Solo. So everybody knows this is no news here that a lot of organizations are going through a monolith to microservices journey right now. I talk to people going through this journey literally every single workday of my life. And so part of that evolution is we've seen the emergence of container orchestration platforms like Kubernetes that give us an environment where we can deploy fleets of microservices and manage them in a hopefully coherent fashion. And so one of the things that comes with the base Kubernetes standard is this notion of an ingress object. And it's fine for what it does. It's a basic way to allow ingress from external users, applications, devices into the services that are deployed in your kube cluster. But it's pretty limited in terms of what it can do. And so there are definitely a lot of advanced features that don't exist in base ingress objects, right? So for example, things like being able to use the OAuth or OIDC standard to talk to your identity provider and authenticate users, the ability to do things like mutual TLS, to use JOT validation, to do authorization like open policy agent, that sort of thing. And so one of the ways that people work around this is the application stacks themselves will often, in a variety of ways, go off and implement these capabilities, right? So you'll have one that uses OAuth to talk to Okta or Auth0. You may have another one that uses a different library to do the same thing. You may have some varying TLS implementations. You may have a variety of kind of web application firewall integrations going on, and so you end up with kind of this hodgepodge of implementation inside your microservice network, which is not always optimal. Well, and then there are other features as well you'd like to have. For example, things like web application firewall and rate limiting that often don't fit well into a microservice sort of environment. And so sometimes those will be implemented externally in some kind of an external gateway. And so this is not an ideal sort of environment. And so GluEdge tries to step into that and offer a cloud native API gateway that lives inside of your kube native cluster, that works on kube native principles. We'll talk about what that means as we go along, and then allows you to externalize all of these features that we were talking about, from your microservice network into a cloud resident API gateway. And so that's what GluEdge is basically it's a way to enforce, but both to specify policy and to enforce policy like this at the ingress point of your application network. Okay, so we've had a lot of experience with this. The product's been out for a few years now. We have a lot of mission critical systems that are deployed across some very big names that you would recognize. Some of the things we really like about GluEdge is the fact that, following the Kubernetes model, that it uses a configuration as code approach 100% of the time. So GluEdge abstractions, and you'll see this as we get into the workshop, are all expressed using as Kubernetes custom resources. So you can specify them with YAML. You can store them in your favorite GitHub or your favorite Git repo, and you can use GitOps technologies like Argo or Flux or whatever you choose in order to manage those and make sure those stay up to date in your environment. You'll also, because of this approach, you'll also never hear us talk about things like, okay, now go spin up an external Cassandra database in order to hold your configuration objects, right? So GluEdge was designed from the ground up to be cloud native, to be Kubernetes native. And so we actually express everything as custom resources. All of our abstractions are expressed as custom resources and are stored at runtime in the native Kubernetes etcd storage system. So it's a distributed object store that makes sure that that your stored components are distributed across your cluster and are accessible by all the services there. So it's very much a cloud native approach. Another question that people frequently ask is, okay, well, I'm all about cloud native, and we're on our journey there. But the fact is, we're not a green field. We're not starting from scratch. We actually have a whole host, a suite of working legacy applications that yeah, we may migrate them over time, but right now they exist outside of our kube environments, and we need to be able to leverage those as well. And so GluEdge is able to handle that. Even though GluEdge is best deployed inside the cluster, it can manage services that live outside of Kubernetes. So for example, things like AWS Lambda functions is one very common ask that people have. Also, just services that are deployed on a say on a bare metal VM, right? You want to be able to access those as well. And so GluEdge gives you facilities for not only managing the services inside your cluster, but also outside your cluster as well, and to apply all of those same the same policies that you apply to your in-cluster resources can apply to the outside the network clusters, outside the network services as well. Okay. Another key component to the Glue Edge architecture is that it's built on top of Envoy proxy. If you're not familiar with Envoy proxy, it was created as an open source out of Lyft a few years ago, and it is an extraordinarily powerful. And basically, what happened was Lyft came to a realization a few years ago that the current generation at that time of API gateway technologies, of proxies, were really designed with kind of static environments as their design center. So, imagine you have a proxy and your world consists of, 8 or 10 or a dozen or 20, big monolithic systems, and they sort of sit there statically and they do their thing. And so you have a gateway that talks to each one of those. It's not a terribly dynamic environment, but what Lyft recognized was that was not the world they were moving to with microservices and Kubernetes. It was a very much more dynamic environment with ephemeral compute instances and that sort of thing. And so they needed a proxy that would fit the modern environment rather than the previous generation. And so they built Envoy with that in mind. And so it's in C++. It's very, very fast. We have customers who just scale this thing up to extraordinary levels to manage very large systems. There's a very vibrant community that exists around Envoy. Envoy is not only the foundation for a lot of modern API gateways, but it's also the foundation for major service mesh technologies like Istio. So it's something that it's out there, it's in production, it's battle tested, it's extremely fast, it's extremely scalable, and it fits very well with a kind of a dynamic cloud native computing model that exists today. Okay. So we're going to talk about a lot of these features as we go through. I'm not going to read all of these off to you. You can see that for yourself. But we'll be talking about pretty much all of these capabilities today. I think we cover all of them except for we won't be doing a WebAssembly exercise today. But if that's something you're interested in, we certainly blogged about that, and we have some detailed examples you can walk through that will tell you more about WebAssembly if you have a requirement for kind of implementing your own custom logic to plug into the API gateway. Okay. Excuse me. So, all right. So I think that's enough of me talking. Let's actually get to the workshop exercise itself. So hopefully at this point you're looking at an interface that looks something like mine here, and you should have a green start button that indicates you're ready to go. So let's hit on the start button, and hopefully your environment has now spun up. And so we're going to begin this first lab exercise in Instruct. We're going to cover two topics. One is just base Glue Edge deployment. We won't cover all the details, but just walk you through a very simple scenario. And then we'll also go through some basic traffic management exercises. So we're going to be there are two flavors of Glue Edge. Actually, let's go ahead and get this started, and then I can talk about the different flavors of Glue Edge as we're waiting for things to spin up. So we're going to be looking at Glue Edge Enterprise today. So it's an open core model. There is an open source version of Glue Edge, and then there's also an enterprise version that implements a lot of capabilities that enterprise users need, things like advanced security and rate limiting and some other things we'll talk about today. So what I've done here, we're going to install the enterprise version. So we need a license key that's already been provisioned for you. You should be able to see that there. And then if you just click on this second box here, that's going to go off and spin up a Glue Edge Enterprise instance in our K3D cluster that's already running here. So you can see we're actually installing this using Helm. There are also some command line options that sit on top of Helm. There's a command line CLI called GlueCTL that we'll be talking about some today, that they're actually using some today, that actually sits on top of this Helm to kind of make the installation process a bit easier. So you can see, it looks like our installation has completed here. So let's go and actually make sure that everything is up and ready to go. So we'll just copy this block and paste that in, and good. It looks like everything is ready to go, and so that's good. So let me show you. I just want to talk. This isn't in the workshop script, but I think it's important to understand just a little bit more about the architecture. One of the things we make a big deal about at Solo is that this is from the ground up a cloud native architecture, and I just want to give you a little bit of a proof point there. So what we're doing here is we're looking at the Kubernetes pods that are available in the Glue system namespace, and so you can see the product is actually deployed as a fleet of microservices, right? So what you can see, let me just go through some of the key elements here. The first one I want to talk about is this one right here, this gateway proxy pod. So this is the actual Envoy instance. This is the data plane through which all of your requests are going to pass. Okay. Now you can scale this up independently of the control plane. So right now we just have a single instance running here, but you can set up through our Helm charts. You can set up HPA, and you can say, hey, based on usage, I want to scale this up to up to 10 Envoy Envoy data planes in this in this cluster. Okay. And so you have the flexibility to scale those two, the data plane and the control plane, independently, which is really, really important from a production readiness standpoint. So this is the data plane. This is where all of the action happens here. All of the requests are going to be serviced by this Envoy proxy. The rest of this is for the most part, it's basically stuff that supports the control plane. Okay. So at the heart of it is this guy right here. This is the Glue pod. The Glue pod is actually connected via, by default, a gRPC connection to the Envoy proxy, and it serves up configuration to the proxy in real time. That's the way Envoy was designed from day one. It was not designed like previous generations of technology where there's a static config file, and every time the static config file changes, you got to go bounce. The server instances, the proxy instances. It's not the way this works. This is very much a dynamic model, whereas changes are happening in the control plane's context. So in other words, things like a new service spins up, or a policy enforcement or a new policy is added, or an existing policy is changed, something like that. As new services are introduced into the environment, the control plane is basically responsible for kind of taking in all of these stimuli that are happening in the environment, translating those into Envoy configuration, and then passing those in real time up to the Envoy proxy. So you'll see that in action today as we make policy changes in our environment. Those are going to be served up live to the Envoy proxy, and they'll take effect immediately, right? There's no bouncing of proxies or anything like that. And so the Glue pod is kind of at the heart of that architecture. There's some other elements here. I'm not going to go into a ton of detail on them. We'll actually cover some of it as we go through. There's a discovery component. We'll talk about that in the section on traffic management in terms of how Glue Edge is able to discover new services in your Kubernetes environment and immediately create routing targets that you can send traffic to. So we'll talk about that a little bit more. There are a couple of components related to observability here. So Glue Edge very much tries to provide a batteries included installation and getting started experience. So for example, we provide things like this observability component. You can see there's Prometheus, there's a Grafana instance in here somewhere right there. And so what we do is we provide this kind of batteries included experience, so that out of the box you can kind of see the power of the environment. Now, we don't necessarily expect you, in fact, we don't expect you to take this all the way through to production. You also have the flexibility with Helm chart customizations to, for example, configure your own external instances of Grafana, Prometheus, Redis to support rate limiting and that sort of thing. So it's both batteries included and with the flexibility to get you ready for production environments as well. Okay, all right. Let's one other one here, and we'll talk about what happens, what this service does more later. You can see there's a microservice here called XDOF, and so that's really at the core of a lot of the security facilities that Glue Edge offers. So here's a very common use case, and one we'll talk about a little bit later on. or one we'll actually put into practice later on. So let's say you have an identity provider, right, to handle authentication, and maybe you're using Keycloak or Dex, maybe you're using an external cloud service like an Okta or an Auth0. So and you want to be able to specify your integration with those via OIDC, OpenID Connect, the OpenID Connect standard. So what happens is you specify those policies, and the XDOF pod works in conjunction with the Envoy control plane in order to implement that. So let's say you have some kind of a policy like we'll do later, where you're allowing certain users into your environment to execute on certain services. So what will happen is you'll specify those policies to make that happen. Those will be in the control plane. The control plane will serve that config up to Envoy, and then when a request comes in that applies, where a security policy applies, it's going to delegate that request off to the XDOF pod, and the XDOF pod in turn can potentially delegate that off to an external IDP. And in our case today, we're going to be using Keycloak, so it'll delegate that off to Keycloak, confirm that user is good or bad, and then take action accordingly to accept or reject that request. So that's what's going on in the XDOF pod there. Okay, that's enough talk about that. Let's actually start doing some stuff here with Glue Edge. Actually, at this point, let me just pause and take a look at let me take a look at the chat stream. All right, everything looks good. So let's talk about traffic management. Now, to do this, we're going to deploy a couple of services today that we'll use sort of as our test bed, our kind of our systems that we're going to be building policies around and testing with. So these are kind of representative of services you might have deployed in your environment, although yours will no doubt be more complex. And so we're going to start with something called HTTP bin. All right, so let's go ahead and install that. So go ahead, if you haven't already, click on this, and let's install that service into the environment. So if you're not familiar with what HTTP bin is, so this is a service you can actually get to it out on the internet, and it's just a way to help debug what's going on inside in a request. So for example, if you would like to issue a GET request and see what you get back from HTTP bin, it's going to help you understand, oh, here are the here's the response body, right? Here are the headers that you get back. If there were any arguments passed in, let's say it's a post request, you might get some arguments passed in here. What was the origin IP address? What was the original URL? Also some metadata here in terms of response headers. What was the content length? You'll also get back the response, the HTTP response code, and that sort of thing. So this is a service just out there on the internet, right? It has nothing to do with Glue Edge specifically, but we'll be using this a fair amount today as we go through these exercises. So what we've done here, you can see we've actually created one of these services inside our kube cluster here, and we're going to deploy another one as well. This is just the echo service, which is even simpler. All it does is you basically you tickle the echo service, and it gives you a static string back. So in our case, we're going to deploy something that's called version 1 of this service here, and you can see there's the service echo v1, and all it does, it's very simple. It will just statically echo, hey, I'm version 1. All right. So to give you a diagram of what's going on here, kind of hopefully help put things in context for you. Here's what we've done so far, and we'll be building on this, obviously. So we got a namespace called HTTP bin with the HTTP bin service installed inside there. We also have another namespace called Echo with the Echo v1 service, and we're going to manage all of that with our Envoy proxy, okay, sitting at the edge of our application network, at the edge of our cluster. And we will be programming that Envoy proxy using the Glue Edge control plane, and all of this infrastructure is employed in a namespace called Glue System, which is the default namespace. You can obviously configure that to use whatever namespace you would like. Okay, so that's where we're headed in this first exercise here. And to do that, we're going to introduce a couple of really key glue edge abstractions. All right. The first abstraction we're going to introduce is called the upstream resource. Okay. An upstream is simply a destination where traffic can be routed. Okay. Very, very simple. And the underlying workloads that are represented by this upstream, they can be kube services, right? They can be, things living on bare metal. They can be Lambda functions, et cetera. Okay, and so there's a documentation link here if you want to learn more about upstreams. But we're going to do some just basic things here to give you a feel for what's going on. So one of the questions that people ask at this point is, well, do I have to create my own upstreams because there's tons of services in my environment? Well, the answer is no, you don't. So Glue Edge, you may remember when we looked at the architecture, there was a service here called the discovery service. So the discovery service is actually watching the kube APIs, and as services are installed, so for example, we just installed these two services. So what Glue Edge will do is it will detect via the discovery pod that these new services are available, and it will create this upstream abstraction on the fly if you use the default configuration and allow it to do that. And we'll create that in your environment according to a particular naming convention. So what you can see here is the HTTP bin upstream will have a name like this, which basically represents namespace, the service name, and then the port where it's listening. And that's how it names these discovered upstreams. So you can kind of see in the diagram how we're expanding that out there. So if you'd like to see kind of what's going on with our upstream, right? Let's take a look at. We're going to use the Glue Edge CLI. There's a command called gluectl. So we're going to use that to take a look at this particular upstream, which was added automatically and kind of discovered, and now we can see that it's active in our environment and it has an accepted status. Now, one of the things that I think is really so gluectl is nice. It provides a little bit of I don't know, an easier interface to get at some of this information. But remember what we said at the outset. Excuse me. All Glue Edge abstractions are expressed as Kubernetes custom resources. And so we can also use, we can use kubectl, right, to look at this as well. So for example, we can do, kubectl get upstream, and we'll use that, and it's in this namespace, right? Okay, and so that there it is using kube tools because this is a kube custom resource, and so we can look at the YAML spec of that, and you can see here's the actual configuration of the component that was discovered that represents this service. And so you can see it recognizes, hey, this is a kube service. Here's the service name, here's the namespace, here's the port. You can see it's been accepted into our environment. It's got a status of 1, which is good. And and so that's basically how the automatic discovery works. Okay. But you can see also here, there are a whole number of upstreams. So Glue Edge has been, hard at work ever since we installed it to discover all of these things that are going on in our environment. So a lot of these we won't interact with directly, but we will, for example, we'll interact with this HTTP bin upstream. We'll also interact with this Echo upstream, right, which was created when we installed the Echo service and so forth. Okay. So hopefully that's all clear. All right. So that was an overview of the upstream resource. Very important at this early stage. It's one of the 2 or 3 really foundational components you need to understand. The second foundational component you need to understand is this idea of a virtual service. All right. So a virtual service basically at its base defines routing rules to let you take incoming traffic, determine where you want to route that, potentially transform it, potentially apply other policies, as we'll get to along the way, to add security, to delegate the request to an IDP, to apply authorization policy, to do transformations, to do WAF, et cetera, et cetera. So what we're going to do here to start with is just a pretty basic, in fact, a really basic virtual service. And so what we're going to do now is let's go ahead and apply this guy. So let's apply this virtual service. All right, so that's out there. Now let's take a look at what it does. So so you can see, first of all, you can target virtual services to look for requests coming in particular domain. You know, for example, you might have one for a single host. In this case, it's very generic. We're just going to say we don't care, you know, any host that it's directed to. If it comes to our proxy, you know, it's something we want to take a look at in this virtual service. So we match on any domain. We also are very generous with the way we match on routes. So basically, we're looking for HTTP requests that begin with the prefix /, which is pretty much, you know, anything. We'll get a lot more sophisticated about that shortly. And then once we find that, you know, matching any domain, matching any input path, then we're going to route that to this upstream, right? And remember, this guy, HTTP bin 8000, so that's the upstream that was discovered for us. And so we're going to route all of those requests to that upstream, okay? So we've already cut and pasted this, so that virtual service should be active now. And what we're going to do here, so because this is, normally this is a little simpler when you're working in your own environment, but because we're operating in an instruct environment and we want to let you come in from the outside of the cluster, we're going to execute this command, which is going to give you something that's customized for your environment, right? A URL where you can basically access the proxy from outside your instruct environment. So let's go ahead, and if you click on this link here, this is going to bring up a browser tab. And so this is a browser tab that's talking to the instance, right? We're no longer talking to httpbin.org, right? That's not there. We're talking to this this instance that's deployed inside of our cluster. And so just like we did before, you know, we can go in and take a look at these services. We can issue a GET request against it, and you can see, you know, here's the information that's reflected back to us from the HTTP bin service. So this is in fact doing exactly what we expect it to. We can also do this from from inside the proxy. I'm sorry, from inside the instruct environment as well. So let me introduce another command to you here. This one is a variation of GlueCTL called GlueCTL proxy URL, and so that's going to show us like where is the HTTP listener actually listening, right? And so we get this local address back here. Okay, so we can take that and we can issue a curl command against that. So let's use GlueCTL proxy URL, and let's go to the GET interface of HTTP bin. And what you'll see is, in fact, the proxy is letting us in, right? And you can see we're getting back a 200 OK, and we're also getting back this information, you know, just like we did when we went to the through the web browser. Okay. Hopefully that is all clear to you. All right. So that's just a basic single route configuration that lets us get to HTTP bin. Let's make it a little more sophisticated now. So we're going to add in a route that allows us to get to the echo service as well. All right. Again, we're going to get a host name that's going to be customized for your particular instruct environment. That'll basically let you set up a pattern here in your virtual service that we can use. All right. So let's talk a little bit. Actually, let's look at the virtual service and then talk about what it's doing. So we now have a second route action that we've added here. All right. So you can see here's the original one that we created right there, right? That's the HTTP bin one. Now we've also added another one that's going to be attempted first. All right. And notice what this is doing is it's still matching on any route prefix or any request prefix. So anything beginning with /, but it adds another condition here, which is looking for the authority header. Now, if you're familiar with the HTTP2 protocol, this is equivalent to the host header in HTTP1. In other words, what's going on here, this is what's going to be passed into the proxy is it's going to have a header called authority that has a host name that has a host name in it. And so what we expect when this comes from outside is that that authority header is going to have this this value right here, echo dot, and then kind of your custom information, and then dot instruct.io. So what's going to happen? It's going to match on that condition first, and if those two conditions match, then it's going to route to this echo service. Okay. Otherwise, if it doesn't match on that, it's going to route to the original HTTP bin service. Okay. All right. I hope that is clear. So let's go in here and let's apply this virtual service change. And when we do that, now if we curl this endpoint, echo dot blah, we should be routed to, right? We're routed to the echo service, and you see we get back this static version 1 string. So that's working exactly as we expect it to, where the authority header is the value of this this host string here. Okay, now, but what happens if, let's say we want to call HTTP bin? Well, then what we need to do is we need to make sure that that authority header is something other than echo.blah. All right, so let's do this. Let's go in here to our curl command, and let's change this. Let's call this, it could be anything, but let's call it HTTP bin.blah. And then let's say we want to get at the get endpoint, okay? And there you go. So that works just like it did before. So here we're using a single virtual service that's using some routing rules to route to 2 different services. Okay. All right. I hope that is clear. You could also do this from outside, use it from a browser window as well. I don't think that really adds a lot to this to the understanding here, but you can try that out if you'd like. Actually, well, let's go through and do it. So we'll echo that out, and then we'll take that link, and there you'll see. So it's actually linked. It's actually it's returning this version 1 from the echo service. You know, if we change this HTTP bin, right, we'll go back to this interface that we expect. Okay. All right. I hope that's clear. So let's take a look. So we've been digging into some configuration here. Let's look at a diagram that kind of shows us what we have at this point. So we're going to start talking about a gateway component shortly. Basically, the gateway says what kind of protocol do we want to listen on, and where do we want to do it. So by default, what you get with BlueEdge is you get 2 listeners out of the box. You get an HTTP listener that's on 8080, port 8080, and you get an HTTPS listener that's on 8443. We'll tickle both of those over this exercise. From that gateway, you can have multiple virtual services that are selected, and so the gateway can forward a request to can actually try to match multiple virtual services. So right now we just have a single virtual service that looks for for any host here, and it has a couple of routing rules inside, and depending on the nature of the request, it's going to route those to one of a number of upstreams. So right now we have an HTTP bin upstream, and we have the Echo V1 upstream. And so based on the rules, it's going to route to one of those upstream components. So hopefully that diagram kind of gives you a sense of what's going on inside. So we've talked about virtual services and upstreams a bit already. Let's talk just for a moment about the gateway component. So the gateway component, again, like everything else in BlueEdge, it is expressed as a Kubernetes CR. As I said, with the default installation of BlueEdge, you get 2 of them. You get one that's HTTP, one that's HTTPS. All right. And so, let's take a look at, we're going to start with this, the HTTP. Yep, the HTTP one. So let's take a look at its specification. And so it's pretty simple specification. You can see here's the spec right here. You can see there's the there's the port information, 8080. Again, it doesn't have to be 8080. That's simply the convention. There are obviously things you can do here to make that more sophisticated. But this is the way that it's configured out of the box. So the HTTP proxy is going to admit traffic on 8080, HTTPS on 8443. All right, and we'll get to HTTPS in just a little while. So those are basically the 3 core components we're going to start with: the gateway, listener, the virtual service that provides the routing rules, and then the upstream that represents the targets that you're routing traffic to. Okay. All righty. So let's talk a bit. One of the first things that people do as they get into Glue Edge, and especially if you are in a fairly large enterprise and you're supporting multiple application teams, you don't want to specify anything in a you don't want to specify everything in a single virtual service, right? That makes no sense. You get this massive configuration. You want to be able to refactor these things in a way that makes sense, that promotes having ownership of the proper resources in the proper places. And so one way you can do that is with the Glue Edge delegation mechanism. And so we provide an abstraction called a route table that allows you to separate out the routing rules into a separate piece of configuration. So potentially you could have one configuration we see is there may be a central platform team that owns the overarching virtual service, and maybe, let's say, the security policies possibly that are applied to that. And then you might have a route table that defines the routing rules that are specific to the application itself, and those can be configured by the application team. So it gives you a way to kind of separate responsibilities as also a way to reduce the complexity of what it is that you are specifying. So here's some of the use cases for this delegation component, and you can read through those. All right. So this is going to change our diagram just slightly, and what it's going to do is, now, whereas before we had the virtual service that was routing directly to the upstreams, now what we're going to do is we're going to separate out the routing rules for one of those systems, and we're going to delegate those to a route table component. Again, it's another Kubernetes CR that Glue Edge supports, that will then manage the routing to the underlying upstream. So you can kind of see how that promotes both simplifying the core virtual service specification, as well as dividing responsibilities or kind of separating concerns across different teams. Okay, so this is where we're headed in this little exercise here. So let's take a look at the first step in this process. And so you'll notice here's the virtual service. So this looks very similar to what we started out with one notable exception. So we still have the HTTP bin spec, just like we did before. Nothing's changed there. But for the echo service, we've changed how this is specified. Now we are, instead of specifying the routing rule directly here in the virtual service, we're saying, hey, I want you to delegate this off to this route table called echo route table in the echo namespace. So what does that look like? All right, here's the route table component, and you can see the rule reflects exactly what we had before, only now we've delegated it out to a separate component, which would of course make this easier to separate and manage across teams, perhaps in separate places in a Git repo. All right, so we have applied this now. Now the good news is, if we do that, actually let's just pause here and confirm this works like we expect. So quite literally, there should be no change, right? What we've done is we've simply refactored. We haven't changed the behavior any. So if we take a look at what we have here, and let's just go back and confirm that. So first of all, let's hit the echo service here, right? And so there, that still works as expected. And let's also hit the HTTP bin service as well, and that works as expected too. So we refactored this into a way that's more delegation friendly, but we didn't impact the behavior at all. Okay. Now, you'll notice what we did here is the way we did the delegation is we actually we specified by name the route table that we wanted to delegate to from this virtual service. Now, that's fine. A lot of people do that, but there's also a way to do it that's slightly more flexible that you may want to consider as well, and that is delegation by label selector. So let's talk about what that means. So here we go. So here we're going to change our route table just slightly, and what we're going to do to it is simply add a label that says, hey, this route table has an application owner label, and the application owner is team 1. All right. And so that's, but other than that, the route table is the same. So let's go ahead. We'll apply that. Okay. So there's a modified route table. And we're also going to slightly modify our virtual service. So rather than delegating to the route table by name, we're going to delegate to it by a selector, right? So this is a lot more powerful. It basically gives us the opportunity to, we can come in and create route, or the application team can come in and create route tables all day long that apply to this service. But as long as they use the proper label, the virtual service that uses them doesn't have to change at all, right? Because it's simply referencing these route tables by a label, by selector, rather than hard coding the name. And so that's what this little change will do, is just give you a slightly more sophisticated way to delegate from your virtual service off to your route table. And again, if we do this correctly, the underlying behavior doesn't change. All right. So if we go back here and curl these two endpoints, all right, so here's the echo endpoint, all right, that works just like it did before. And also HTTP bin works just as before. Now, I want you to notice what's happening here. You're noticing that as we apply these policy changes, right, we're not going and bouncing our Envoy proxy, right? Envoy proxy, this configuration is being served up dynamically by the control plane. Envoy proxy is putting it into effect immediately, and then it's available right away to all the services that invoke this. So a really powerful idea there. Okay, let me take a drink here. I promise I will give you a break at some point as well. I don't expect you to sit here for 2.5 hours without a break. Let's talk a bit about multiple upstreams. Let's Alexa, stop. Let's talk about multiple upstreams here. So one of the things that you would like to be able to do potentially is to, let's say, common use case for this is, let's say you want to do a blue-green deployment. Alexa, stop. You want to do a blue-green deployment. And so what you're going to do is you'll have version 1 of a service and version 2 of a service, coexisting at the same time, and you're gradually, shifting traffic from one over to the other over time. So this is going to give you just kind of a core foundational piece of how you would do that. All right. So what we're going to do is, first of all, we're going to install a new version of the Echo service. Let me just show you that here. So if we take a look at this config, here's what we're going to do here. So there's nothing special about this. This is just the what we're calling the V2 of the Echo service. And you can see it's configured to return a different string, right? So it's going to return the static string version 2 instead of version 1. And we're going to manage routing traffic across those two services. All right. So let's go ahead and let's install V2 of the service here. In fact, we can confirm that. What we expect to happen is that service is deployed. And when that service is deployed, BlueEdge is going to detect that via its discovery component. It's going to use that to create an upstream and feed that requirement to, or feed that config to the data proxy, or to the data plane. And so now we can see, hey, look, we have discovered that there's this new Echo V2 8080 service that is out there. It's been accepted and it's ready for us to route traffic to. All right. So now here's the payoff. This is how we actually do the routing to the multiple upstreams. Okay. So notice this only affects the Echo service, okay? So we don't even have to touch the virtual service that sits at the top level. We only need to touch the routing rules for the Echo service. And so everything in the beginning here changes. You can see we're still delegating by selector, by label. But what we're going to do here is we're going to create a multi-route, a multi-service routing action here. And so what we'll do is, we have, half of our traffic is going to the V1 service, half of our traffic is going to the V2 service, And all of this is being managed in the in the proxy config. Sometimes people will ask about these weight values. Does it have to be 5 and 5? Do they have to add up to 10? And the answer is no. It basically, these values, their absolute values don't matter. It's simply the relative values of all of the destinations you're selecting among. And so if you have 5 and 5, it's going to route half the traffic to one and half the traffic to the other. Okay. So let's see if this works. Let's go and apply this change to the route table that will do kind of equal weight routing across our two backend services. And yep, just pictorially, what we have going on here is, so this part is the same. HTTP bin is the same, but now we have in the Echo namespace, we have two services, Echo V1 and V2, and those are each, based on this virtual service, are going to be getting 50% of the traffic that comes through that endpoint. So let's test this out. We got a little script here that's going to hit the Echo service 10 times. And what we expect, it's not going to be exactly 5 and 5 all the time, but it's randomly generated. And so you can see, it's 6 and 4 in this case. But you can see about half the time it goes to version 1, about half the time it goes to version 2, and you can hit it again, and you'll see, you should see something similar each time you hit that endpoint. So in fact, this is working exactly the way we expect. Now, some people will ask at this point as well, what if I'd like to manage this dynamically? So what I'm showing you here is we're managing the the distribution percentages. Right now it's half and half. What if I'd like to let's say V2 works fine for the first hour. Maybe I'd like to automatically update that to 60% or 70% or 80%, maybe have some schedule deployed for, hey, if there are no problems, I want to ramp this up to 100% over the course of a day, or perhaps I want to roll back to 0 if there's an extraordinary number of failures. Those capabilities aren't built into GluEdge natively, but there are a number of there are open source technologies out there that will help you manage that sort of thing. I know we've had customers who've had success with Flagger, which is an open source project from Weaveworks, to kind of do that sort of higher level orchestration of say blue-green deployments and managing the migration from V1 to V2 of a service. So that might be something you want to check out as well if this is something that's a concern to you. But I just wanted to show you how you can route to multiple endpoints and manage that distribution from a route table. Okay, that brings us to the end of Lab 1. So if you are done, like I am, I encourage you to hit the next button here. And what that's going to do is say, hey, your configuration looks good. I'm loading your next challenge. If you missed a spot somewhere along the way and it says it's not correct, you can also hit the, what was it? Was it the skip? I think it was the skip button. And that will actually go and apply, or will try to apply the changes to the environment that you might have missed. And so you should have a clean slate then going into Lab 2. So far, we have done a bit of an introduction to Envoy Proxy and GluEdge. We have installed GluEdge, and we've explored some basic traffic management features. We've set up a listener. We have routed to some upstreams, even done some fairly sophisticated things like weighted routing to multiple upstreams. So you have a good foundation at this point for launching into this next section, where we're going to talk a lot more about topics like security and authentication. We're going to talk about rate limiting, and actually build an example over the course of this Lab 2 that I think will be pretty impressive to you in terms of what we can do strictly with policy configuration on an API gateway, and then of course apply this to as few or as many services as you have in your environment. So that's where we're headed in this next section. Let me do a little bit of a commercial here. Actually, go ahead. Let me invite you to go ahead and hit the start button so we can get Lab 2 spinning up here. Kind of get that spinning up in the background, and well, that didn't take long. And so let me do a little commercial here. So if you're interested in diving into more of these topics or more detail on these topics, the resource to go to is docs.solo.io. And if you go there, it's going to show you, here are all of the Solo products where we have documentation. And so you can go here. So if you're interested in Glue Edge, which is what we're talking about today, you can view those docs. It's going to take you here, and there's a whole lot more detail. For example, we're going to be talking a lot about security over this exercise. There's pretty comprehensive information on the various security features of the product that you can explore at your leisure. We also do a lot of blogging at solo.io. A lot of times we talk about, we'll provide tutorials on new or existing features and for Glue Edge and Glue Mesh. So you can see here's one that I published just a couple of weeks ago about handling large payload requests with Glue Edge. So this is something, if you have your own environment set up, you can go through and check out. We had a customer who needed to handle up to 100 megabyte payloads using Glue Edge, and we showed some techniques for how to do that in a pretty efficient way. So there's a lot of good blog content here, both at the tutorial level as well as just larger pieces about what's going on in the industry right now, and with service meshes and API gateways and so forth. So definitely recommend you take a look at that if you're so inclined. All right. So hopefully everyone is back and has has entered into Lab 2 here. And so let's begin. We're going to talk about security and authentication. We're going to jump to OPA after that, Open Policy Agent for authorization. Talk about transformations, and we'll talk about rate limiting in Lab 2. So let's start off with security. So one of the most basic levels of security, obviously, is actually securing the communication channel between your external clients and your proxy, and so making sure that people can't snoop. Can't sniff that traffic that's going over the wire. And so the most common way to do that is with TLS technology. And so we're going to show you, it's actually very simple to get that set up and running using Glue Edge. And so we're going to walk through a basic example of that. So I'm not going to go through the kind of the details of the PKI infrastructure here. We're just going to set. I'm going to give you some scripts or a script. We're going to set up a root certificate authority, certificates for this HTTP bin application in particular, and then we'll also update curl to add that root CA to the CAs that it trusts. So I'm just going to execute that script without further explanation. This next exercise, I'm not going to do it. You can if you'd like to. Basically, if you can set up Chrome to trust these certificates that we just created as well. I'm not going to do it. It doesn't really add that much to it. It just makes some of the Chrome. You don't get security warnings on Chrome if you do that. But I don't really want to pollute my Chrome installation with this stuff, so I'm just going to skip that. We can still do all the exercises without it. We are also then going to take this cert, private key that we just created. We're going to store those as a Kubernetes secret. And so we'll use this command to do that. It's just a straight kubectl command. So let's do that. Okay, so we created a secret there. And now in order to use that, it's actually very simple. All we're going to do here is we're going to go into our virtual service, and you'll notice. So we have the same basic config same routing config that we had before. But what we're going to do here is, for all of the services that are under the management of this virtual service, we're simply going to apply this SSL config, and we're going to tell it to go look at this secret, at this cert that's stored here using this secret. All right. So let's go ahead and apply this change to the virtual service. And once we do that, now we can expose the application, in a secure fashion through TLS. And so we're going to first investigate that. We're going to use HTTP bin here to do that. So let's do this echo command to actually generate, again, for your specific instruct environment. Here's the URL that you want to use. And when we click on that, it's going to open another browser. Now, this is obviously a vestige of the fact that we didn't update Chrome to trust these new certs that we generated. So that's fine. I'm simply going to click through advanced and say, yep, I know it's a self-signed cert. I don't really care. Go ahead and proceed. And so, now, so we've used, you can see we're using HTTPS here, and we're getting access to this HTTP bin instance that's inside our cluster. All right. So we can go here, and try it out, and it should work exactly like it did before. The primary difference being the communication between the client and the service, or the client and the proxy, is now going to be encrypted. So, a malicious actor can't come in and sniff our traffic. So pretty cool, easy to do, right? So that's all good. All right, so we've done all that. Oh, we can do the same thing here. We can do the same thing here with curl. All right, so let's just show that very quickly. You can see we're using HTTPS instance here, and we're hitting that same the get endpoint on HTTP bin, and you can see it responds just like we expect it to. So yeah, that's easy to do, but it encrypts our outside the network communication there. Okay, now here's a topic that we see a lot of our customers caring about these days, and that is the use of a standard called OpenID Connect to integrate with your underlying identity providers. So this standard is very widely adopted across identity providers. We find every major one that we work with our customers seem to support it without a lot of trouble from our standpoint, which is good. And so we can have a single configuration that adheres to this standard, and then we can support a whole variety of IDPs on the back end. So just just some of the ones that I've personally worked with that I know work. We're going to do Keycloak today. I know Dex works. I know that Okta and Auth0 work. I know that ForgeRock works. Pretty much anything we've tried. We've even seen some internal implementations of where people have done their own OIDC implementations with internal IDPs. We've had those work. So as long as it supports the standard properly, then this technique for authenticating with OIDC will almost invariably work. All right. So what OIDC is going to do for us, this is a layer on top of OAuth 2 that provides a well-defined ID token in response to your authentication request. And so it follows the JSON Web Token, the JOT standard, and it gives you back certain claims. There are certain standard claims that are inside that JOT token, and you can also specify your own custom claims, which is one of the things we're going to explore in this section, is how you can not only use those, where you can basically use those custom claims to drive authorization decisions in the request flow, as well as to drive routing decisions and that sort of thing. So it's a really nice, really powerful authentication pattern set of patterns that you can apply through Glue Edge at the edge of your application network. So, all right, let's go ahead and start. This actually takes a couple of minutes to roll this out. We're going to install an instance of Keycloak in our inside our environment here. So go ahead and kick that off. That takes just a minute to spin up. And while that's spinning up, let me tell you a little bit about what we're going to do with that Keycloak instance. So there's a lot of config here that I'm going to install pretty much without comment. You either understand it or if you need to know more about it, you can go research that on your own. It's really outside the scope of what we're trying to accomplish here with Glue Edge. But in short, what's going to happen is our Keycloak instance is going to be configured with 3 users. Okay. All right. Looks like that successfully rolled out. Let me go ahead and do the next step here. All right. And that should get Keycloak to the point. All right. Well, that looks good. So it looks like Keycloak's about ready. So anyway, what we're going to have here is we're going to have 3 users installed. Very sophisticated setup here. We got user 1 with password of password, user 2 password, admin 1 password, and then we have certain claims that are associated with each one of these users. So for example, with user one, we're going to have this user1@acme.com email claim. We're also going to have that this user is an enterprise subscription user, which will have some heightened feature, capabilities. User two is from a different, user2@umbrella.com. It's a free subscription, so it can do less stuff. And then we also have an administrator that's in here called admin1@solo.io, and the administrator has the most flexibility of all. So we're going to do some things with a kind of fine-grained open policy agent policies, where we can actually take this information that we get back from the IDP and use that for routing and authorization decisions. So pretty cool stuff. All right, so I believe I've already done this to get back the admin token, and then we're going to actually configure these client and the users that I just talked to you about. I'm not going to go into explaining the script. Just trust me, that's going to set up all of those users with all of those claims inside of the KeyCloak IDP. All right. This is something, if you get an error, rerun this command. Looks like I didn't get an error. Commonly, I don't get an error with this. I think this was just some earlier version of the workshop where this happened. But it looks like we're all set to go here. All right, so let's take a look at what we're going to be doing here in our diagram. Okay, so what we're going to be doing with KeyCloak, we're going to be protecting the HTTP bin service using, and so we're going to allow access to differing degrees from these three separate users: user one, user two, and admin one. And we're going to handle the authentication process using the OIDC standard with our KeyCloak instance that we have deployed here. There are a variety of alternatives that you can use to this approach. Tons and tons of approaches that you can use for applying security. I do recommend you go look at some of these other resources if you need to explore that. Reach out to us on the Slack channel. But there are a whole variety. If you just look into authentication and authorization alone here, you can see some of the different options that are available, and it's a pretty extensive library of things you can do with kind of the Glue Edge security services. Like I said, we support a whole variety of customers with a lot of different requirements here. So, all right. So what I'm going to do here, we're going to do OIDC today, which is very common, and so we have a secret that we got back here from KeyCloak. So we're going to take that secret and we're going to create a secret in Kubernetes. It's going to be called OAuth. That's the name we're giving it, and we're going to specify it using this client secret that we got back from KeyCloak. So let's go and do that. That should take just a half second. All right. So that secret has been created now. And then we're going to use that secret to build a new abstraction. Okay, so this is the first time we've talked about the auth config. And the auth config allows you to build a bridge from Glue Edge to a variety of identity providers using a variety of security schemes. And so what we're going to do here, as you can see, we're using an OAuth 2. We're naming this OAuth 2. And we are going to use the OIDC standard stanza here to configure this. So again, there's lots of documentation. I'm not going to go into it in detail, but you can see if you've done OIDC configuration before, this should look pretty familiar to you. So you can see there's the client ID. There is the reference to the secret that we deployed, that we stored in Kubernetes, and some other details. You can also see we're going to get back the ID token header, which is where all the claims live. We're going to get that back in a header called JWT JOT, and so we'll be looking at that in more detail in just a moment. So let's go ahead and create this auth config object here. All right, so there's the auth config, and now we're going to activate that auth config with an option that we're going to apply to our virtual service. Now, I think there's a couple of interesting things I want to point out in this little piece of configuration here. Now, notice we still have two different sets of matchers, okay? We have a matcher that's for the echo service here, right? So that's going to delegate off to that route table that we created in the last lab. And then we also have this HTTP bin set of stanzas here. And so you can see that routes to that same upstream that we had before. But notice what we've done here. Now we've applied something new. We've applied an option that's called the xauth option, and we have referred to this auth config that we just created right here. Okay, so notice what we're doing. We're actually applying this at the individual route level. So this auth config, this key cloak delegation, is only going to apply to HTTP bin. It's not going to apply to the echo service. Now, if we wanted to, you'll see later, we can apply that same configuration at the virtual service level. So everything in this virtual service is going to use this same security scheme. But in this case, showing some of the flexibility and how fine-grained you can get in applying these security policies, if that's something that you want to do. So let's apply this virtual service change. All right, that's good. And at this point, let's actually go hit the HTTP bin service now and see what happens. What we expect to happen is that on the initial request, we're going to be redirected to Keycloak according to the OIDC standard, and we're going to enter our user information. In this case, we'll enter user1 and password, and then we'll see if we can get into the service. Okay, so let's follow this link. All right, and sure enough, look what happens there, right? It's redirected us to Keycloak. We will enter user1 and password. We'll sign in, and now that's going to take us. So that was right. That's a valid user input. So that allows us through to HTTP bin. We can then go, hit one of these endpoints, and it should work right exactly as expected. Now, one of the things I want you to notice here. You'll notice we get quite a bit more input back because we're also getting the information that comes back from the IDP, because the IDP is now in our request path. And so as we specified in the auth config, we want to get back the ID token from Keycloak as in this header called JOT. So you can see we get back this base 64 encoded JOT token. And so we can actually take that, and let's go look at the jot.io site and actually see what claims are embedded inside this token that we get back from Keycloak. All right. So here's jot.io. All right, let's paste this in, and you can see, right, there are a whole bunch of tokens, a whole bunch of claims that we get back from the IDP that we can then use to drive routing and authorization decisions. Pretty cool, right? We'll show you how to do that in just a second. But you can see here, right, here is the username, user1, right? Here's the email address, user1@acme.com. It's in the group users. Here's the subscription. The user1 subscription is an enterprise subscriber. And so all of that information is sitting there managed in the IDP, right? The source of truth for our enterprise. And we can get that back in Glue Edge and make use of all these claims that are embedded inside. Pretty good stuff. So we're going to show you how to take advantage of that here. All right. So, and so that's basically, that's basically all it takes to configure Glue Edge to delegate off to your IDP of choice. Now, what we are going to do here is again, we're going to show you a bit of refactoring to kind of show you how you would do this typically in a larger enterprise sort of environment. So basically what we're going to do is you've noticed we've created everything so far in a single virtual service where we had all of the routing for HTTP bin and echo kind of all managed in a single virtual service. That's not commonly how it happens, right? Commonly, you'll have each application or group of related group of applications might have a single virtual service that they would, that they would use. And so we're going to refactor. This shouldn't change our core behavior, but we're going to refactor this to use that sort of scheme. All right. So let's delete the virtual service that is that's already out there. So we'll get rid of that, and then we're going to create two virtual services to take its place. Right. The first one is the VS Echo service. So you can see that route looks pretty much exactly like what we had before. To delegate off to a route table that then sends things to the proper version of the Echo service. So let's apply that. And then also we will set up an HTTP bin service. And notice we've specified the our auth config at the virtual service level here. Okay, so just showing you some of the flexibility, some of the options you have for refactoring and that kind of thing, which is very valuable as you get into this. So, but basically the behavior should be unchanged, right? So if we do, if we look at let's see, the echo service, right? That should work. That should work just as it did before. Let's see here. Yeah, so there you can see there's the echo service, right? And it's alternating, right? It's still doing the traffic across the different services. So it alternates back and forth between version 1 and version 2. And just trust me, HTTP bin is also still working as well. So we can refactor this, without changing the, without impacting the underlying routing rules. Okay. So just as you would expect. All right. Now, let's get into something that I think is some fun here. So Open Policy Agent is an open source project that was inspired by I forget the guy's name now who started it, but basically it was inspired by all the problems that people had with coming up with coherent authorization policies in the early days of Kubernetes. And basically, he and his team asked the question, what if we could come up with a general purpose policy engine with hooks where we could integrate to a variety of systems and then use that. So provide a single policy language, it's called Rego, that you could use to implement pretty easily fairly complex authorization and access control rules. And so that's the genesis of Open Policy Agent. And so it's been a part of the Glue Edge product for well over a year now. So pretty stable. We have customers using it for sure in production. And while the purpose of this isn't to give you a tutorial on Open Policy Agent, I do want to show you a basic OPA rule and then how you would integrate that, basically activate the Envoy filter in Glue Edge that delegates off to Open Policy Agent and applies these rules. Okay, so here's what we're going to do in this OPA rule, in this Rego rule. We are going, so first of all, Rego rules are stored as config maps. That's how they're accessed within Glue Edge. And so with this particular Rego rule, we're going to allow any request for any virtual service that's under the control of this Rego rule. It's going to allow any request that is a GET request. So basically, a read-only request. You can hit all of those you want to. But if you want something else, right, if you want to do a put or a post, something that's going to change an underlying resource, then you need to be an admin user in order to do that. So you can see the first rule here is allow anything that's a GET request. The second rule says, okay, I want to decode this JOT. Remember the JOT we just looked at? And so within the payload of that JOT, we're going to look for a claim called group. And if the value of that group claim in the payload of the JOT is admin, then we're going to allow you to do anything if you have that privilege set up. Okay, so that's a fairly sophisticated policy that you can specify, very easily within a config map and then apply it using Glue Edge. All right, so here's what we're going to do. We're going to modify our auth config. First of all, I need to let me apply this config map. I haven't done that yet. So there's the config map. And now we're going to access that from within this auth config. Okay. So first of all, you'll see what we've done here is we said we have two configs now. The first is this OIDC config. All right. And then if that passes, if the authentication passes, then we're going to take this kind of enriched request information that we get back from the IDP, and we're going to pass all of that along into this OPA rule called HTTP bin access control. All right, and it's going to apply these rules that we specified right here. All right. So let's see how this. Well, first of all, I need to. Okay, so we've applied the config map. I need to apply the auth config as well. So remember, this auth config is already attached to our virtual service. So this config should be, picked up immediately by Envoy proxy and applied the next time we hit this application. Okay, so let's go and let's get the URL here. All right, and just to make sure, I'm gonna open this up in an incognito window just to make sure we don't have any session session caching issues here. So let's open up an incognito window. Let's paste this URL in, and then not surprisingly, what's going to happen is we're going to be redirected to Keycloak. Again, let's log in. First time, let's log in as user 1. Okay, user 1. That's going to take us to the top level HTTP bin interface. Now, remember, user 1 is not an admin. So what does that mean? That means that user 1, we expect to be able to issue GET requests, but that's it, because they're not an admin user. So let's test that out and see if our OPA policy is working as expected. All right, so here's a GET request. Let's try that out, and boom. All right, that works just like expected. We've got a 200 code. You can see the expected results there. All right, so that's good. But what will happen now? What if we try a post, right? So our expectation is, because this is not an admin user, if we try a post, what we're going to get back, look at this, right? Perfect, just like we expected. We get back a 403. This request is not authorized. Okay. All right. So that's working. Our OPA rule is working just as expected for user 1. Now let's try something else. All right. Let's open a new window, new incognito window, and let's try again. Now this time, what we're going to do? Sorry. Let's try again. Let's go here. All right, again, just to avoid potential session issues, let's do a new window, HTTP bin. All right, Keycloak. Now, this time what we're going to do, let's log in as admin1, right? Admin1 with a password of password. Now, what do we expect to happen this time, right? So, of course, GET methods, right? Any user can issue a GET. So we expect this to still work like it did before, and it does. That's all good. But now we also, because we're an admin, we can also issue post requests, right? So let's try that out. So whereas that failed before when we were a non-admin user, now look at that. Now we get back a 200 from our post request as well. So looks like our simple, tiny little OPA rule is working exactly as we expect, which is a really good thing. All right. Let's get rid of some of this stuff here. Okay, so I hope that's clear. Now, remember, we're building on an example here. So what we've done now, we've delegated off to an IDP. We've authenticated our user. We get back some claims. We use those claims to drive an OPA-based authorization scheme. And now we want to do some other things. So let's explore some of the data transformation capabilities within Glue Edge to kind of take the next step in this process. So what we're going to do is we're first going to extract the claims from this JOT. You remember I showed you those on jot.io, and we're going to store those in HTTP headers and use that to drive further actions downstream. Okay, so let's see how that works. Just copy this little script here, paste that in, and so what you can see if you look at this section right here, this JOT staged section, you're going to see what we're doing. All right, so we've got, Keycloak is our provider. The token source is going to be this header called JOT. All right, you remember that one. And then what we're going to do, we're going to extract claims from that JOT. So specifically, we're going to extract a claim called email and a claim called subscription, and we're going to use that to populate two headers that we're going to add to our request on the fly. So one of those is called x-email. The other is called x-subscription. All right, so let's see if this works as we expect it to. So we've applied this change to our virtual service, and let's see if in fact this does what we expect it to. All right, so let's go get this. Let's take a look at our get endpoint. And all right, look right here toward the bottom. You see that? All right, there's our X email header with the user1@acme.com. We're still logged in as user1 here. And then also you can see the subscription claim was extracted into this header, X-subscription, with a value of enterprise. So that is working exactly as we expect it to. So pretty powerful stuff there, I think. All right. So we've now extracted claims from the JOT. We've pushed those into request headers, and you just saw this for yourself in our other window here. And now we can do transformations based on these headers as well. So let's say a pretty common example is, let's say we'd like to derive, based on this set of claims we have, we'd like to be able to derive the organization name. And let's say we don't have that. There's none of the headers that have that information exactly. The email address is pretty close, user1@acme.com. So what we'd like to be able to do is just, is there some way we could apply, say, a regular expression to extract just the acme.com aspect of the email address and call that the organization, right? So that's a decently sophisticated transform that we'd like to be able to apply. So can we do that in Glue Edge with a configuration only approach? And the answer is we can. Now, in order to do that, I want to talk to you a little bit about the filter chain architecture of Envoy, because this is a really critical concept to understanding Envoy, is that it's designed from the outset to allow you to be able to plug in different filters that are applied at different places in the request processing chain, if you will, right? And so you can see here's a collection of filters that happen inside of that Glue Edge specifies. Okay, so we can activate all things like cores and DLP and WAF and so forth, and we can apply these transformations at different stages of the process in many cases. So, for example, this transformation that we're contemplating here, where we're going to extract the organization name from the email address, there are potentially two places we could apply that. We could apply it here at the early transformation filter, or we could apply it later at the regular transformation filter. Now, what's the difference? The difference is the extraction of those claims and the translation into headers happens here, but at external auth, and then this JOT filter here. Okay, so if we try to apply this transform at the early stage, it's going to fail because that information is not there yet. But if we apply it after these auth filters have been applied, then the information will be there. We can do the extraction, and we can use that organization name and that subscription, right, to drive, say, rate limiting decisions downstream. Okay, so pretty powerful stuff, but it's important to understand what's happening here in the Envoy filter chain that's going on. So let's take a look at the transform that we're going to be applying. All right, so the changes are fairly simple. You can see we're here. We're in our virtual service for HTTP bin, and what we're doing here, this is the change. So you can see we went through this before, where we're extracting these claims from the JOT token. We're extracting an email and a subscription, and then what we're going to do is we're going to apply a transformation, and the transformation says, go into this email header, right, which is right here. Go into this email header, and you can see the regex pattern says, right, look for everything that's after the @ sign and before the end of the regular expression, which is basically the acme.com or solo.io part of the email address. And so extract that subgroup, what's within those parentheses right there, and then so extract that and then apply that to this new header called X-organization. So that's basically what we're doing in this transform. And again, all this is specified via, this is straight just configuration. You can store it in your repo and that sort of thing. All right, so that's what we're going to do. So we've already applied this. So now let's see it in action. All right. So here is the URL we want to use. Let's go to that. Okay. All right. Let's see what we have here. Right. So there is our email claim, just as before, user1@acme.com. There's our subscription. Notice right here. Here is our new claim, X-organization. It's extracted. Right, it's extracted what comes, right, the suffix of the email address here, acme.com, and it's now populated that into this organization header. And then we're going to use that to drive downstream rate limiting decisions in the next section. Okay, I hope that's clear, because it's if you need this kind of capability, it's pretty powerful. All right, so that's all working as expected. So now let's, this is the final movement in this lab exercise is rate limiting. And we're not, not surprisingly, given our time constraints, we're not going to go into a ton of detail on rate limiting, but we do want to give you a nice exposure to actually a reasonably sophisticated configuration. You can do simpler things than this too, or more complicated things. But what we want to do is we're going to postulate that we have multiple types of subscriptions we offer from our organization. We have a free subscription and an enterprise subscription, and the rate limits are different between the two. So for free subscription, you have a rate limit of 2 requests per, it's not per second, it actually should be per minute. The enterprise subscription has a limit of 8 requests per minute. And so we're going to enforce that here. In fact, you can see here in the spec, it says 2 per minute, not 2 per second. And you can see we're going to drive these rate limiting decisions off of these sets of descriptors here. So in other words, for the 2 per minute rate limit to apply, these things need to be true. There needs to be an email key, there needs to be an organization key, and there needs to be a subscription key with the value of free. And if those conditions are met, then we're going to be limited to 2 per minute. If, on the other hand, these exist, but the subscription key has a value of enterprise, then you're going to get the higher limit. You're going to get 8 per minute. And then you can also see how these rate limiting descriptors are going to be selected, and they're going to be selected based on these header values, right? So email, there's X organization. Remember, we just kind of synthesized that one from the email address in the previous exercise, and then the subscription type, free versus enterprise. So this is all it takes to build, a reasonably sophisticated rate limiting policy. So let's go off and let's apply that rate limit config. And then we're going to change our virtual service to apply this rate limit. So this is this is HTTP bin, right? You'll notice here we've added an option at the end, right? So we've got all these options. We've got an XDOF option. We got transformations. We got the JOT extraction rules, and then now we've also adding a rate limit config that just references that rate limit config custom resource that we just created in the previous step. All right, and that's it. That's all we have to do. This should actually just work now. So we can. Let's get this link again, and we'll go here. Now this is user 1 is an enterprise user. So what we expect is this user should get 8 requests per minute. So if we just go up here and hit the request enough times, right? Boom, right there. You can see it. HTTP error 429, which if you're familiar with your response codes, HTTP 429 is a too many request error. So basically we're being rate limited at this point. So that works exactly as we expect. Now let's do this. Let's see if the free subscription level works as we expect to. So we'll open up an incognito window, right? We'll paste this same URL in. Now that's going to redirect us. No, it's not. What do we got? This is still our admin user. Let's close that out. Let's see. Make sure I can get a new. Let's get a new session here. See if we can force that. Okay, all right, we're so now we got a new session. So let's go. Let's log in as user 2, which is let me check my notes here. Yeah, user 2 is a free level subscription. Enter the password. All right, there's the first request that went through with no problem. Second request is fine. Third request, boom, right? As soon as we exceed that threshold, we get back our rate limiting error. All right, so that is a pretty easy way to specify a reasonably sophisticated rate limiting policy. Okay. All right, one last little refactoring exercise we're going to do here, and this is a very simple one, but very nice. What this allows us to do, so you've noticed now we've chained together a whole bunch of options on our virtual host that apply, an XDOF policy, a transformation rule, a set of abstractions from our JOT token, and a rate limit config. So what we might like to do, that's kind of a useful package of policies. What we might like to do is package that up as its own CR, its own custom resource, and then be able to just by reference pass that policy collection into a virtual service, right? So you can see how we're kind of making this a lot simpler to specify here. So let's go and let's take a look at that. I think I must have hit, what did I hit there? Okay, let's go back in here. Must have hit that link there. So that's not what I wanted. All right, let's go back in here. All right, select that. Take a look. Okay, here we go. So you can see we've taken that kind of collection of policies and we've packaged that up into a single CR called the virtual host option, right? That has all these things packaged in. And now what we can do is we can take that virtual host option and in a single spec here, we can delegate off to that virtual host option. So it's a really nice compact way to be able to specify that. But the behavior shouldn't be changing. So let's paste that in, and that's good. So what we'll see now, if we go back to, let's see here. If we go back to if we go back here, the policy should be exactly the same as before. So if we hit this, we're user 1 here. If we hit this more than 8 times in the same minute, we should get back an HTTP 429 rate limiting error, which is what we get. So that all works as expected. All right. And that's basically it for Lab 2. If you've stuck with me, kind of followed the tour to this point, congratulations. I think you've accomplished something. And hopefully you understand a little bit more about how to do some of these policy specifications with GluEdge. All right. So I invite you to hit the next button, or if you haven't been able to follow along exactly, you just like to skip to the next exercise, you can hit the skip button. I'm going to hit the next button and make sure I've done everything correctly. All right, it looks good. And now there are 2 more sections left. These are both quite a bit shorter than the previous lab, so we can work through these fairly quickly and get you out of here by the 3:30 Eastern time deadline. Okay. All right. Let's talk about Web Application Firewall. This is a really powerful capability, and I'll tell you when I personally got really excited about Web Application Firewall was last year. If you were involved with Java systems at all, you no doubt know all about the Log4Shell vulnerability that people were saying set the internet on fire. I actually blogged. We've had a couple of people who've blogged about this, and let's see, where is it? Yeah, if you take a look, if you're interested in this topic, we got a couple of blogs out there that talk about this issue in more detail. This was the initial one that I wrote within a week of when the exploit was first out there, and so it talks in detail about the nature of the exploit and what it tries to do, and how you can use GluEdge to thwart that without, and I think this is the important point, you can apply this at the egress point of your application network so that the applications underneath you don't have to wait for them to apply, the various log4j patches or reconfigure log4j to use it with an existing version, etc. You can basically, when a day zero vulnerability like this emerges, you can immediately, using WAF applied at the gateway level, to be able to stop these kinds of attacks right away. So this exercise is actually based off the experience that's kind of documented in this blog here. It's kind of this is a shorter version of that, but it goes into detail about the Log4Shell vulnerability. And so basically what happens there is you have a malicious expression that looks something like this. So for example, Jindy, Java naming, Jindy, identity Java name directory interface. Anyway, this identity service could be used if a header was passed in with a certain format that Log4j, logging service in Java, would interpret as a remote service lookup. If it's configured like default configuration, it could actually go off and cause a remote object lookup on a server that's controlled by an attacker. And so this exploited a whole bunch of enterprise systems that were out there. And basically, by specifying some pretty simple web application firewall rules, you can thwart these kinds of attack vectors. And so let's talk about how you can do that. So first, let's just walk through the exercise. Let's set up a simple virtual service that does not protect against this exploit and just show you how that works. So this is just going to delegate off to HTTP bin. Very simple service. So we'll apply that, and then we're going to simulate one of these attack vectors using this right here. So you can see we're passing in a user agent header that has this malicious string that could be. So if this were backed by a Java application, and that Java application logs out, let's say it logs the user agent on any request that's received, and Log4j could interpret that and then go outside the network to basically do a remote object lookup on this malicious attack server, and you'd be in a world of hurt. And that's in fact what happened to a lot of enterprises. So if we execute this curl command against our unprotected server, you can see right here, right, what happens is user agent has this malicious string, and so if Log4j just log that value out, right, you've got big problems. All right. So how can we protect this this potentially vulnerable service? Well, so let me show you. There's a lot more sophistication here. This is not the final word on this, but let me just show you an example of how you might approach this. So let's go ahead. Let's apply this rule here. And so you can see what we're doing here. So web application firewall is based on actually a pretty old technology, open source technology called mod security that's been around since the early days of Apache servers. And so mod security basically looks for malformed, potentially malicious requests, and allows you to take appropriate actions. And so the way it works is there are three components of a mod security rule. The first is kind of the source where you want to look for information. So for example, here we're looking at the request line, we're looking at arguments, we're looking at argument names, we're looking at request cookies, we're looking at request body, request headers, etc. And then then there's a matching rule. So in this case, the matching rule says, hey, we're looking for a regular expression that begins, $, curly brace, and then one of these, like Jindy or LDAP, one of these protocols that's been exploited using this Log4Shell attack. And then if we see that regular expression, or something that matches that regular expression, then here's the action we're going to take. That's the third component of the rule. So it's source, rule, or source, predicate, and then action. And so the action is, hey, I want you to deny this request, give us back a 403 message with some explanatory text there. Okay. And so that's what we've done. Simple mod security rule. We've applied that at the ingress point of our network. Every application that's behind this mod security rule is going to be protected. And now what happens if we try to issue this same request again? What do you think we're going to see, right? Instead of a 200, now we get back a 403 forbidden message, and hey, this is a log4shell malicious payload. Okay, so pretty powerful, pretty easy to apply, and you can do it all right there within your gateway with policies that can apply across a host of services. Okay, so this just explains what we just did here. All right, so that's all good. Yeah, one other thing, just to show, so we showed that we captured the malicious request. Also, we can also show that if we have a perfectly valid request, so here's a perfectly valid user agent, right? And if we do that, right, it works just as expected. So it's capturing the things that we want to capture, but it's letting things through that are legitimate requests. And so that's a good thing. Okay. Yep. And again, if you want to check that out, there's the blog. There's the blog where you can read more about that. And there's some others that are referenced in there as well. Okay. And also documentations on just the general web application firewall capabilities. So that's all I wanted to say about Lab 3 on security via web application firewall. So hopefully if you've done all that and you hit the next button, you'll see a green bar like that says everything's good. And that will take you to our final exercise for the day, which is all about observability. So let's go ahead and hit the start button, and we will dive into this observability section. Now, within the context of observability with Glue Edge, there's a lot of really good news. One of the primary pieces of good news is that the creators and maintainers of Envoy proxy publish a whole raft of really good quality metrics out of the Envoy proxy. And so we basically, using Glue Edge, we get those for free, and we take full advantage of that and leverage that. So let's actually take a look. And one of the things, a couple things we do with that. So we provide like I said before, we like to provide a kind of batteries included initial user experience, right? So you actually get these Prometheus and Grafana instances out of the box with Glue Edge. So let's go in here and we'll do a little set up a little port forward so we can take a look at some of the stuff that's generated automatically using these, say the embedded Grafana. So let's take a look at, let's go there. You can log in just the default, admin. Just skip this step. You don't need a new password. Skip that. And so here we go. So this is inside Grafana here. Where are we? Okay, here we go. So there are a whole bunch of things that we get out of the box here. So for example, like I said before, here's some of the default things you get with just with Envoy alone, right? You can see request times and response codes and that sort of thing. So there's a whole bunch of statistics that you can use to take a look at what's going on inside your cluster. It's being managed by Envoy. Glue Edge also publishes a number of dashboards, and you can customize these. There's a blog that's written about how to write your own custom dashboard just using standard Grafana syntax, and so you can extend the thing. So Glue Edge, for example, generates per upstream dashboard information, just dynamically generates them as the upstreams are discovered or added by you to the environment. So for example, let's pick this one, where we know there's some HTTP bin stuff that's sitting out there. So we can go take a look at that, and you can see, right, you can see here the number of HTTP requests, here are the HTTP response codes. You can see, response time statistics, heat maps. There's obviously not a whole lot going on in this cluster, so these graphs aren't terribly interesting. But you can imagine in a real world production scenario, this is going to be a lot more interesting. And as I said, you can customize these to do, kind of to do whatever you want. So this is just what comes out of the box. I just wanted to give you a flavor for that, and to know that's something that you can go look for. Okay. So let's. There's also, if you want to take a look at the log, at the default template that's used to generate these, you can do that as well. So there's obviously a lot of stuff here, but this is just, if you know Grafana, how to specify Grafana dashboards, this is all just standard Grafana configuration here, and you can extend this to your heart's content, and add whatever dashboards are appropriate for your environment. So that's certainly one component that a lot of our users take advantage of, is this Grafana integration. There's also another one that I'd say is possibly even more commonly used, really, kind of first, when you're on the ground with Glue Edge, you really want to take the time to set this up, and that's this notion of access logging. So you may recall from the beginning of this exercise, we made the point that Envoy Proxy is really optimized to be fast, right? And so because it's optimized to be fast, it does very minimal logging out of the box. Okay. So including, even by default, access logs aren't turned on, but access logs are going to basically give you information about every request that's processed by Envoy Proxy. And so it's a very valuable facility. And we see, I'd say, 99% plus of our customers have access logs turned on in their in their development and production environments. So what we're going to do is we're going to enable access logging on the gateway, and let's just show you what that looks like. So this is going to be the first time that you remember we talked about this gateway component, right, which defines what the listeners look like. So this is the first time we're actually going to customize this. You may remember in the beginning, we just had a very minimal specification out of the box for the gateway, but now we're going to add some stuff to it. So specifically for every service that is accessed via the HTTP gateway here, we're going to add a set of, kind of a specification for access log records, right? And so this is all, you can see, things like the HTTP method that's used, the protocol, the response code. There's all kinds. This is just touching the service. There's a lot more information that you can get from the from the Envoy docs as to other macro values that you can specify in this access log record. So this is a really valuable thing to be able to do and to see what's going on. So let's actually generate some traffic here, and to do that, we'll go. Let's use the Echo service. So let's just go in here and we'll hit the Echo service a few times. All right, and once we hit the Echo service, then let's go and we're going to use this kube command to actually dump out the logs from the gateway proxy. Again, that's the core Envoy proxy, and we're going to do some grep and pretty printing to make it a little more readable. And what we're going to get back is, right, you can see right here, this is the information for all of these requests that we have been issuing. So you can see there's information, there's the response code. You can see, this is a very short duration service. So, that there's not much information there except that it's fast. You can also see the upstream that this was routed to. So remember, this is the one that's set up with the split routing where 50/50 goes version 1 versus version 2. So you can see, hey, this request went to version 2, version 2, version 2, right? There's one that went to version 1. There's another version 1, another version 2. So access logging is a really good way to get a lot of core information out of your Envoy environment. And potentially you're going to forward that off to your your enterprise logging mechanism, like a Datadog or a Splunk or Elasticsearch or whatever, and be able to store these and then debug what's going on in your system from these access logs. Okay, So those are the two things I wanted to cover on observability today. Talk to you a little bit about the out of the box kind of graphical observation capabilities, as well as kind of this core access logging capability as well. And so that, if you have made it with us to this point, we are at the end of the lab exercise. So congratulations. So that's a wrap for the core Glue Edge workshop. This gives you a solid foundation to move into the second segment of this workshop, and that is another interactive session on the GraphQL extension to Glue Edge. In this session, you'll learn how to deploy GraphQL APIs by leveraging your existing API contracts and without spinning up a separate dedicated GraphQL server. As you did in the previous section, watch for your instruct links in the video to use at the appropriate time during the upcoming workshop presentations. Again, we thank you for joining us today. Now let's dig into Glue GraphQL together. All right, hello everyone, good day. Welcome to the Glue GraphQL workshop by Solo.io. My name is Jim Barton. I'll be doing most of the talking today. With me is Adam Saya. He's a field engineer with Solo, so we'll be working this together. He'll be answering most of your questions behind the scenes and digging me out of any holes I talk myself into. So hopefully that won't happen too much. Let's start just by introducing ourselves. My name is Jim Barton. I am a field engineer in North America with Solo. I've been here for about 2 years now. And in the decade prior to that, I spent quite a bit of time architecting, building, and operating enterprise systems at Amazon and Red Hat. So let me, Adam, if you have your mic on there, why don't you introduce yourself as well?
Yeah, sure. My name is Adam Saya. I'm a field engineer with Jim, working in the field to help our customers and prospects to adopt a service mesh and API gateways, and also being part of kind of our GraphQL initiative here at Solo. So yeah, don't hesitate if you have any questions. I'll be happy to answer them.
Yep, Adam is actually kind of the godfather of our GraphQL experience in the field. He's the one who originally built this workshop and has worked with a lot of our early adopter customers on this. So yeah, we're really lucky to have him here today, and he will answer any questions. And as I said before, he'll dig me out of any holes I fall into. So yeah, thanks Adam for being here. Thank you all for joining. We really appreciate your time today, and hopefully we'll be able to give you some information as well as some experience that will maybe help you understand GraphQL a bit better, or at the very least understand kind of an alternative architecture for how you can deploy it that we think will perhaps make your life quite a bit better, okay, and easier. So let me start off with a little bit of an origin story. I was watching a documentary on GraphQL recently that featured a number of the original Facebook engineers who built it back in the 2012 timeframe. And in this documentary, they highlighted a statement that came out in a regulatory filing that Facebook made back in the early 2010s that listed as one of their biggest risk factors that we are unable to continue to develop products for mobile devices, because there was this huge consumer shift that was going on, right? So Facebook was really good at building applications that used websites. And so initially they just tried, hey, maybe we can have a mobile website that basically does the same kinds of things we already know to do with our standard desktop website. And that was just a miserable failure in the early days. And so they identified this as a risk factor for the whole company, that as the whole consumer market was shifting to mobile devices, it was simply overwhelming their service infrastructure. And they didn't have a great solution in the early days. So they put together kind of a task force, a special team that went off into a separate room down at the end of an unused corridor at Facebook and really attacked this problem. And the problem they identified was that the APIs they were using were kind of like a vending machine. That's the analogy they use. So you press a button, you get a product, right? And the problem is when you're trying to build something really complex, like say, a user's Facebook newsfeed, you don't need to press one button, you need to press, a dozen buttons, right? And so that's a really slow and painful and inefficient sort of process. And so a lot of times what would happen is on top of those interfaces, like, well, I don't want to have to push the button a dozen times. I'd like to have a smart button that I can push once that will go off and grab, maybe from a REST service, all of the bits of information that I need. And then I can, on the client side, I can kind of aggregate all of those together, filter out the things I don't need, and then display that. Well, the problem with that approach is it's kind of bloated and inefficient. And so that didn't work that well either. And so the way GraphQL began its life was as a prototype in this environment that they built to support a complete rewrite of the iOS Facebook app back in 2012. And their initial target was a really complex use case of managing queries that would build a user's newsfeed. Just think about a Facebook newsfeed and all of the hierarchical information and the interconnections from one user to another and one post to another and that sort of thing. A very, very complex use case. And they needed a new kind of technology based on a new kind of API to enable that. And so they built GraphQL, which is a query language that supports that sort of where you can basically build a query graph that allows you to easily associate elements from different services and be able to stitch those together. It was a raging success. The app launch was successful, and Facebook ended up recognizing, hey, we have something here that's really valuable, not just for this one use case, but for a whole variety of use cases. And so they open sourced the GraphQL framework back in 2015. Immediately, almost, it caught fire, and now there's this large and growing enterprise user community that takes advantage of it. So you can see some of the logos there on the right. A lot of large companies have pretty enthusiastically adopted GraphQL, and so, not surprisingly, there is this growing vendor community that is supporting GraphQL as well. And that community tends to make a very interesting assumption, and that is that GraphQL deployments are these sort of unicorn APIs that require dedicated servers in order to operate them. So what you see, if you look at the diagram on the bottom left there, is a pretty common sort of deployment architecture. You'll have an API gateway of some sort, right, that handles, so let's say, all of your other APIs, your REST APIs and your gRPC APIs, maybe even your SOAP XML APIs. And but then for GraphQL, it ends up delegating through to a special dedicated server that only knows how to manage GraphQL deployments, and then potentially delegates off to other application products in the background. Well, that's kind of a funny assumption, don't you think, that you would need a special kind of server to serve up an API, a special kind of dedicated server? And so what you end up with is with traffic patterns very much like this, where you've got this separate server instance, right, that knows about GraphQL, that sits behind a gateway that provides all of these other capabilities like security and to traffic management policies, routing, that sort of thing, rate limiting, and so forth. But then this separate GraphQL server behind that just to serve up those interfaces. Similarly, if you have deployed, perhaps you're using something like a service mesh, you get some additional complexity there, because you have sidecars that may have been injected into those instances. And so you'll have a sidecar who talks to your GraphQL server, and then that has to delegate, further upstream to talk to the actual product deployments. So in my mind, it's not really an ideal sort of solution. So, but what if? Let's just consider a couple of questions here. What if you could specify and operate GraphQL APIs in a way that didn't require dedicated servers? What if you could reuse existing API gateways to serve GraphQL, just like you do other APIs like OpenAPI and gRPC and so forth? What if you could, rather than writing lots of imperative code for resolvers and so forth that fuel your GraphQL servers, what if you could use DevOps practices like declarative configuration to specify things like schema and resolvers and so forth, and have that be managed by your already existing API gateway. And finally, what if you could actually leverage existing API contracts like Open API, Swagger specs, like gRPC protos, that sort of thing? What if you could leverage those contracts to build out your GraphQL configuration? Well, those are exactly the kinds of questions and issues that we're going to discuss today as we look at the Glue GraphQL service and actually give you some hands-on experience in building with that. Okay, so to state that a slightly different way, you get a number of benefits out of the box with GraphQL. No matter how you actually serve up the APIs, there are a number of things you get out of the box for that. One is things like client-specific data views, like you can fashion a query that retrieves just the information that you want from a single entry point to generate an entire graph of information that satisfies just what you need for your query. It addresses things like the overfetching of data, because now I don't have to call, say 10 different REST endpoints and fetch a whole bunch of information and then, filter out everything but the 1 or 2 bits of information I need from that kind of massive set of blobs. And also, it prevents the underfetching of data too. So when you, for example, I'd like to be able to get, user information with the reviews associated with that user, but the problem is it's 2 different services. And so I have to go out and I have to get, I have to go and get the users, and then I have to go for all of the users, I have to go query another service to get all of the reviews that user has published. And so you end up with this underfetching problem that leads to a lot of inefficiency and extra network hops. And then finally, you get really nice with GraphQL client compatibility with even in the face of evolving backend schema. So that's all generic GraphQL stuff. It's all great stuff. It's the reason why we love it. But there's an additional set of concerns that comes when you're operating an application network that aren't often satisfied very well by the current set of solutions that are out there. And those are standard gateway concerns like authentication and authorization, rate limiting, observability, protection from malicious payloads with web application firewall, data loss prevention, and other things that we'll talk about. And so what if there were a way that we could put these two together? So if we combined the goodness of GraphQL with the standard kinds of features you expect from an API gateway, what would you expect that to look like? So that's exactly what we have done with Solo, with our Glue GraphQL product offerings. We've created an Envoy filter that understands how to manage GraphQL requests and to delegate those to upstream services. Okay, so the actual GraphQL server, if you will, is actually embedded inside of the Envoy proxy, rather than being a separate server instance that someone has to stand up and maintain and so forth. And so what does this lead to? Well, if you look at the top diagrams there, it leads to a simplified deployment architecture. And this is one of the things that our customers have told us that they like about this solution very much. Is currently, they look like the diagram on the top left there, where I've got these multiple boxes I have to manage, right? I got my standard gateway, I've got and plus I have a dedicated GraphQL server. And what I'd like to do is to be able to bring those two together so that I have a gateway that understands how to serve GraphQL APIs, just like it understands how to serve REST and gRPC and so forth. And so that simplification story is a really big winner in our customer base. In addition, this optimizes the performance of the data plane, because guess what? I no longer have to have this extra hop in my network in order to support GraphQL queries, right? Everything is handled right there in the Envoy API Gateway box. It also leads to some really important considerations like declarative configuration for your apps and your infrastructure. So one of the features of Glue Gateway, both Glue Edge and Glue Mesh, the Glue Gateway component, is that it features declarative configuration as Kubernetes custom resources. So you can specify, hey, here's what I want a virtual service to look like. Here's what I want a route table to look like. Here's what I want a security policy to look like. And those are all expressed as kube custom resources that are then stored and managed inside kube etcd. It's all declarative, right? I'm not writing code in order to specify that. Well, now we have the same availability for GraphQL abstractions as well, where I can specify those and use exactly that same declarative model for managing that. Okay, pretty cool stuff. Let's skip on. There's also some really nice scalability characteristics here as we scale up from simple kind of monoliths to multi-cloud, potentially federated graphs. We'll talk a bit about schema stitching in just a bit, and talk about how that allows you to build super graphs that can span multiple services, potentially even in multiple clusters, but yet have a single kind of coherent graph that you can use to drive your client applications. Okay, so how has Solo done what it's done with Glue GraphQL? Well, all of our gateway products are based on Envoy proxy. Okay, so Envoy proxy, very fast, very scalable. One of the unique things about it is that it supports a filter chain architecture where there are plug points where you can specify your own filters that do a whole variety of things. And so at Solo, we've written a number of filters, and we give you API configuration that you can use to activate and configure those filters. And so one of the things we have done here is we have built a filter that is a GraphQL filter. It basically is a GraphQL server that acts as a filter in an Envoy filter chain and allows you to serve those requests directly out of the Envoy proxy. And so that's the bottom line of what's going on here is that that architecture. Okay. So what we're going to be looking at today, we're going to be looking at a number of examples. This is one of the examples we're going to take a look at. It's based on the, if you're familiar with the Istio Book Info API, it's a standard sort of application that's out there everywhere, example application in Istio, and it's kind of a polyglot assembly of 4 different applications, all written in different languages, all deployed in separate containers. And so what we're going to do is show you how you can take that network of applications, specify schema for it, and in a declarative fashion, and then use that, put a GraphQL front end on top of that to actually to drive its operations. Okay. We'll also show you a bit of the GraphQL UI that comes with Glue Edge. So a lot of our clients actually don't prefer to use this UI. They prefer to specify things using, say, YAML configuration, and then to manage it, store it in a Git repo, manage it with a GitOps technology like an Argo or a Flux or a Jenkins, something like that. And that's all. And so we fully support that mode of operation, actually encourage it as a best practice. But in some cases, when you're in development mode, you need to be able to do things in a more interactive interface as well. And so we'll take a look at this UI and show you how that works as well. Okay. All right. So good stuff here. We're about to do the workshop aspect of this. And what I want to do to get started, it actually takes a couple of minutes to spin this up. So what I want to do is I want to get you all started so we can get the spin up process started, and then we'll come back and talk a bit about what we're going to do in these exercises. So I'm going to post a link into the chat here. All right. So hopefully everyone sees that link. It's for a platform called Instruct, and it's specifically targeted at this workshop we're delivering here. So what I'd like for you to do is take that link, and I want you to paste that into a browser. Chrome works really well. We've had success with others as well. And so if you click through that link, you should see something like this that allows you to add this workshop to the study room. Oh, by the way, let me say this as well. I'm assuming that most of you who are on this workshop are engineers, and you actually want to get your hands on and not just hear about the technology, but actually kind of get your hands on a little bit, get a taste of it. And so if that fits you, if that description fits you, then we encourage you to use this to actually use the Instruct workshop, where we're going to provision a computing environment for you and let you actually get hands on. However, if you don't want to do that, that's perfectly fine. You can follow along. I'll be guiding us, so you can just kind of view this as a demonstration, and you can follow along. You don't have to do it hands on, but we get a lot of good feedback on for people who like the kind of the interactive workshop. So if you click through this, you'll see some interfaces like this. Eventually, you will come down to this right here, Introduction to GraphQL and Glue Edge. And so I encourage you to view that track. You should see an interface that looks something like this. You can see there are a number of lab exercises here, and we'll be talking about those in just a second. And then I want you to go ahead and hit the Start Track button. So when you hit the Start Track button, you can see over here, that's going to start up a process. It's going to run for 2 or 3 minutes. There's also a video here, which I believe features Adam. So if you'd rather hear Adam talk about this stuff rather than me, feel free to hit play on that video there, and you can listen to Adam. But we'll let this spin for a couple of minutes. If you have any issues with that, please put something in the chat. Otherwise, we will let this spin, and let's go back and talk a bit about the exercises that we are going to be doing. So we're going to do this today with the Glue Edge proxy that's based on Envoy as kind of the platform that we're going to build our GraphQL interfaces on. There's also support for this technology in Glue Mesh, which is an Istio-based service mesh that's kind of optimized for multi-cluster operations, and also just standard enterprise Istio support. So if you're interested in seeing GraphQL in that sort of a mesh environment, hang on just a couple of weeks, and that will be available to you as well. But today, what we're going to do this based on the Glue Edge Envoy-based standalone API Gateway technology. So first of all, we'll run through an installation process. We'll walk through actually installing Glue Edge and some other components, some application components that we need. So that'll take just a few minutes. That'll be our first exercise. Then we will build out, we'll kind of build out sort of increasing complexity in our examples. We're going to start with a very simple REST service in exercise 2, where we're going to walk through just a basic example with you. We're going to point it at a REST service. The GraphQL control plane is going to discover the components that are in this REST service, actually build out candidate schema and resolvers, and give that to us in a way that we can use it directly without having to author any GraphQL code on our own, and B, without deploying any dedicated GraphQL server. So pretty powerful stuff. Then we'll move to a slightly more complex example that's going to front a network of 4 services based on the Book Info app, and we're actually going to build our own. We're going to build our own schema based on what the information that's returned from that app. So just kind of giving you a more complex example with a slightly different way of doing things. Again, everything's going to be declarative based configuration, so it's very easy to get started with. Then we're going to move to addressing a couple of security concerns. So you may recall I said earlier, one of the things that's really nice about this approach is that we get all of the security benefits that come with an API gateway like Glue Edge, like with Envoy, we get all of those security benefits just built in now, right? It's not some separate server that we're fronting. It's actually just, more filters in the Envoy filter chain. And so we're going to show you how you can build out some security capabilities and actually put those in front of your use those to protect your GraphQL APIs. Okay, so that's the security bits. We'll also then move to an even a little more complex example where we're going to show you schema stitching and also gRPC interfaces. So we're going to go out. We have a network of 3 applications that use gRPC as their interface technology. We're going to discover those interfaces, and then we're going to take the schema from each of those services, and we're going to stitch them together to create a super graph that will then issue some queries against. And then finally, we'll take you on a very quick tour of the administrative UI, and then we will that'll be the end of our workshop. Okay, so that's where we're headed today. Now let's go back to our Instruct platform. So hopefully, if you're like me, you see something like this where we have you have a green start button, so everything is spun up. We can hit the start button, and that's going to take us into this first exercise. It's going to walk us through some installation process. So one of the things we like to do with these workshops is give you a complete soup to nuts experience, right? We want to start you at ground zero, walk through installation, and all the way so that you have a sense of what this is like from the very beginning to all the way through to publishing your first set of applications. So that's what we're going to do here. And so let's just walk through this. You'll notice all of these text boxes, they have a little, there's a little icon up here. If you click that, that will copy the text in the box for you. And then you can take that over to the terminal window here and just paste that into the terminal window. And so it's a very easy way where, you're not having to focus on typing. You can actually focus on understanding, hopefully a little better what we're actually trying to do here. So the first step in this process is we're going to install a tool called Altair, which allows us to basically, it's a GraphQL client that we can use to interact with our services in an easy way. The Altair client has absolutely nothing to do with Solo or with any of the Glue platform. It's simply a tool that, because we support GraphQL, it's something that's very easy for us to work with, and we're going to use that as to help us out with some of these exercises. Then we're going to install our first application here. This is an application called Pet Store. So it's a sample app that's been around. I think it's a Java app. I'm not even totally sure about that, but it's an app that's been around for a long time. And we're going to use that as our example to get started. There's actually nothing in this app at all that knows about GraphQL, right? It is simply it's a REST app, REST API is what it publishes, and we're going to take that REST API. We're going to discover the components of that, and then we're going to use that to build out our GraphQL interface without writing GraphQL code. So you can see this is just a standard Kubernetes service deployment that we're putting out here with the Pet Store app. Absolutely, nothing fancy, nothing special about it at all. We're just putting that out there, and you can see that our deployment and our service was created. Let's make sure that this has been rolled out, which at this point it should be. Yep. Okay. This is already successfully rolled out. You can also, if you want to take a look at the pods that are associated with that, it's just a single pod that contains this Pet Store app that we're going to do some things with. Okay. All right. So that's our application infrastructure and our query, GraphQL query client infrastructure. Now let's install the Glue Edge component. So it's going to come in 2 pieces. We're going to install a client component, which is a command line tool called GlueCTL. So let's put that out there now. All right. So there's our GlueCTL client. If we run this GlueCTL version command, you can see we have client version here 112.0. Server, we don't have anything defined yet. We haven't actually deployed the server components yet. And so we are going to do that now. We're going to use, there's a couple of ways we could do this. We want to keep this simple. We'll just use a standard Helm chart. that will install the enterprise edition of Glue Edge. So we'll put that out there. There's also an open source version of Glue Edge that is available. It does not have the GraphQL capabilities built into it. So to access the GraphQL components, features, you'll need an enterprise subscription to Glue Edge. So let's just wait for a second for that to deploy. And what's going to happen while we're doing that, I'll give you just a quick look at the architecture. So okay, it looks like it's out there. So let's just take a look at the pods here. So these are the pods that are part of the Glue Edge kind of microservice fleet that get deployed. So one of the things I think this highlights about Glue Edge that is really interesting is that Glue Edge is not a lift and shift of some older generation into a Kubernetes cluster. It's actually a purpose-built, dedicated cloud-native API gateway that was built from the ground up to be itself a microservice network. So you can see the fleet of microservices that are deployed here. Just to highlight a couple of them while we're waiting for everything to finish spinning up. So here's something called Gateway Proxy. That's actually the Envoy proxy itself. So this is kind of the core of the data plane component. So requests are going to come into this Envoy proxy and be handled, and then the response will be sent back from here. So this is the core of the data plane. Just below that is something called the Glue proxy, the Glue pod. And so the Glue pod is the core of the control plane. All right. So very important characteristic here of what you're seeing is that we separate out the data plane and the control plane. So it's very important from a scalability standpoint. So you can scale up the data plane independently of the control plane, which is extremely valuable. And another point that it highlights is Envoy was designed from day one to be able to separate data and control plane. Part of the reason why is because if you've ever worked with older generations of API gateways, you're familiar with this workflow. Okay, I need to add some capability or fix something, right? And so I deploy a change to a policy, maybe in a config file or something. What do you have to do for that policy to take effect? Well, you have to bounce the proxy, bounce the data plane in order for that to take effect. Envoy was designed with a completely different usage model in mind, where the control plane and the data plane are connected as they are here. And so as we're authoring changes in our declarative schema, in our Kubernetes custom resources, those changes are going to be served up to the Envoy data plane dynamically from the control plane. And so what that means is, as we're serving up these configuration changes, they're going to take effect in the Envoy proxy immediately, right? Which is a really nice benefit, both from a deployment standpoint, right? Making sure you have reliable deployments that don't go down, as well as just from a workflow standpoint, from a development standpoint, being able to make changes and have them very quickly take effect, and you see what's going on immediately. There are a number of other components here as well. I'm not going to go into detail on them. We're going to be dealing with the discovery component here to help discover the schema. Like I said, the REST, OpenAPI, gRPC schemas that we're going to be dealing with, we'll be using that. We'll also be using the XDOF component here to add some security features onto our application network. And there are a couple of other things we could talk about later if you are interested. But let's just confirm here that everything is up and running and ready to go. We don't have any issues. And yep, it looks everything looks good. So we're running, we're ready to go. And so that's basically the end of the first exercise, just to get everything, kind of get a baseline platform in place that we can then start doing some GraphQL things with. Okay, so if you are like me and you're at this point in the lab exercise, you'll notice over here there is a green check button. So what that's going to do is just do a quick check, make sure everything is in order, and then it will take us on to the second exercise. So let's go ahead and hit the check button, and hopefully everything has been done correctly. And so it's going to load up our next exercise. So for our next exercise, we're going to take a look at just a basic service and show you just kind of, it's almost like a hello world kind of example, just to get you started with the GraphQL integration in Glue Edge. So let's go ahead and start this exercise. So here we go. Now, like I said, everything in Glue Edge is specified as a Kubernetes custom resource. And so our GraphQL integration is no exception to that. So we actually have a CRD, a custom resource that we've built called GraphQL APIs. And if we take a look at what we have running in this environment, what you can see is we're starting off with absolutely no GraphQL APIs, actually, no specifications that would allow us to operate a GraphQL client against this service. All right, so nothing up my sleeves. Everything we're starting off from zero. Now, the first thing we're going to do is we're going to use the discovery service. We're going to point this at this pet store application out there, and we're going to say that we're going to enable FDS. We're going to enable function discovery. Okay. And so when we do that, what it's going to do is it's going to go out to this service, the Glue Edge discovery component. It's going to go out to this service. It's going to interrogate its open API interface, and it's going to use that to build a set of GraphQL artifacts that we can then use to do some GraphQL with. All right, so let's go back and now let's look at the same thing before. Let's look at the GraphQL APIs that are out there, and you can see now there's one that's been discovered. If we go in and we if we drill into that, right? So let's look at the YAML for that, right? You can see now this service has, right, there's all of this schema that's been discovered, and again, this application knows absolutely nothing about GraphQL. It's simply it's a REST API based on Open API spec. And so, but we have nevertheless discovered the schema, as well as based on the functions that are published. We've discovered also some resolvers that we can use to support our GraphQL interface. I think that is a pretty powerful thing. And so, yep, so we actually just took a look at that, so we can see the generated GraphQL schema. And now what we're going to do, let's talk about this. So the pet store itself is so it's a public API, right? You can go out here and, and take a look at that. And right, this is, I'm looking at an external endpoint. This has nothing to do with Glue, right? This is just something that the Swagger organization publishes about pet store. So I can go in here, and of course, I don't control this server, so I don't know exactly what IDs are active, but I can specify a pet ID here. This is one that was working yesterday, and yeah, and here we go. So you can see, right, here's the here's the REST curl command that gets generated, and you can see, in fact, there is a pet with ID 2, and you can see some information about that pet. Okay. So that's all good. So, and of course you can also drill in and look at so this is the Open API spec that supports this pet store application, right? And so, you can see it's a fairly extensive interface. And if you went and drilled down, you would be able to see that the interfaces that were discovered and published in our GraphQL schema actually correspond exactly to this Open API spec. So in other words, we're leveraging the contracts you've already built using REST, using Open API and Swagger tools, and we're leveraging those in Glue Edge for GraphQL. Okay, I think that is a pretty nice little piece of value there. So, okay, so now what we're going to do, we've discovered the API that's out there. Now we're going to actually build a Glue Edge virtual service. So this is a really key abstraction in Glue Edge, a virtual service that actually specifies the routing policy that's going to let us get at these various system interfaces. Okay, so let's take a quick stroll through this virtual service, and then we'll apply it. So first of all, you can see we have some cores options in here. Don't really worry about those. Just suffice it to say those support the Altair client that we're going to use as a client to make sure that those requests can come in from another domain and be processed properly. We've got some of that there. That's not really critical to what we're doing here. But we do have 3 separate routes that I want to talk to you about, okay? So we've specified a route, number 1, that supports the Altair client. So this is the client GUI we're going to use in just a second. So basically, any request that doesn't get captured by these first 2 routes, we're going to send it to Altair and use that client, okay? Now, we got a couple of other routes we've specified here. We're looking for anything with /v3. So you might recall, if you look at the Swagger, interface here, right? This is the, if you've got something that begins with v3 here, we want to capture those. And we're going to route those to the base REST API, just to show you that it's working. Everything's good. You can use REST and GraphQL together, so you can support different clients with different requirements. It all works fine. And then finally, we've also specified this route. Now, this is the GraphQL kind of fun route here. So we're basically looking at anything with a prefix of /GraphQL, and we're going to route that to this GraphQL API schema that is sitting at this address. So in other words, the thing that we just looked at over here, the discovered schema, that's what we're going to route those requests to. So those are our three use cases in our virtual service here. So let's select that, and we'll apply that virtual service. Okay, that'll take just a second to be processed. And now what we're going to do is let's go through and actually confirm this is working like we think. Okay, so the first thing we want to do, let's take this second case here of the base pet store service routing, and just like we saw over in the public interface, you're going to see something very similar here, where we're going to curl this endpoint, and you're going to see that we get back we're going to get back a response here. So let's take a look at that. Here is the curl command, and when we execute that, yep, you can see ID number 10. We get back some rabbits, and there's the name. There's the name rabbit1. So that's the rabbit that's available in our pet store at ID 10. Now, file that away, because we're going to come back to that when we look at the GraphQL interface in just a moment. Okay, so that's all working as expected. And finally, we need to be sure this works. Let's say there's not a pet there, right? So let's specify a non-existent ID. And when we do that, actually, let's do it this way. Let's do it this way. And so you can see what we get back here is, we get back a 404 not found, because there's no pet in our database that has that ID. Okay. So that's all good. So that's working exactly as we expected to. Now what we want to do, we want to see, can we really, right? Is it really as easy as we just, kind of laid out, where we can take this REST interface, and now, with a simple discovery process, use this same interface with GraphQL. All right. So let's see that. So to do that, we're going to use the Altair interface, and we're going to need to get this value right here. And this is just basically the endpoint that we need to get into the Instruct platform from outside, because the Altair platform is going to require that. So just copy that URL, go to the Altair client, and in this URL box here, just paste that URL in, and then we're going to actually specify a very simple GraphQL query. So we're going to use this service get pet by ID. We're going to specify that we want to get pet ID number 10, which is the one we used before, and then the only thing we want to get back from that is just the name. This is really, really simple. Okay. So if we send that request off to our interface, check that out. So there we go. We get back our pet, and there it is, rabbit1, just like before. And so without writing any GraphQL anything, we were able to satisfy this simple use case. and basically publish GraphQL interfaces to our external users. Now, let's also replicate the other example. So let's put in an invalid pet ID. We'll send that request off, so you can see, according to good GraphQL principles, right? We got back the response from the query is in exactly the same form as the query itself. The response in the query format match, but in this case there is no pet there, and so we just get a null. But we also get an explanatory stanza here, which has our errors in it, and you can see that our REST resolver got back a 404 response from the upstream. So this pet wasn't found. So basically, it's all working. Both good and bad cases are working exactly as we expect them to, and that's good stuff. All right. So this is a very basic use case. Obviously, you're going to want to do things that are more complex than that, and so we're going to dig into that some in the next example. So if you're caught up, I encourage you to go ahead and hit the check button, and we will move on to exercise 3. Let me just check the chat stream here. Yep, everything looks good. All right. So hopefully everyone who wants to follow along is following along. Now we're going to move to a more complex example. So this example is going to do something a bit different. This is going to look at a more complex use case based on the Istio book info sample application, which if you've worked with Istio at all, you have no doubt seen it before. It is a polyglot application. You can see this diagram here. Part of the service is written in Python, part of it's in Java. There are multiple versions to deal with. Part of it's in Ruby, and part of it is in Node. So there's something in this service network for everybody. So let's go ahead and install that. And again, there's absolutely nothing Glue or GraphQL specific about what we're doing right here. This is just a matter of, we're putting a set of services and deployments out into our kube cluster, and we will use these rollout commands to wait on them to become available. So this takes just a couple of minutes to spin up here. So while we wait for that, let me just give you a preview of what we're going to be doing in this exercise. So the first thing that we're going to see is when applications are deployed into our kube cluster where GlueEdge is managing things, we have the ability to discover abstractions that are called upstreams automatically. So an upstream is just a target service to which GlueEdge can direct traffic. Okay, and so we have this discovery mechanism turned on, and so we're going to discover these upstreams. And not only will you see, and so you're okay. It looks like it's almost done here with the upstreams. Anyway, then we'll take a look at the resolvers that we're going to build out as in this process. So we're going to do things just to show you that we can do things slightly differently. We're actually going to, in this case, we're going to specify the GraphQL interface, with a configuration as code practice. We're going to specify that that interface ourselves this time, rather than trying to discover it, because in some cases, right, there may be applications that don't even have an open API spec associated with them. So we can handle that as well. So let's take a look. Let's take a look at the upstream. So here you can see if you notice at the bottom of this display, there are 4 upstreams that have been discovered here that correspond to the 4 services in the book info application. So there's the product page, which is kind of the top level service that then delegates off to these other services that get details and reviews and ratings. Okay, so that's all working just as we expect it to. And so what we're going to do is we're going to build out, we're going to take a look at the schema, and we're going to take a look at a resolver that we're going to specify. So here's the result. These will all be part of this CRD that we're going to create that specifies a GraphQL API. And so you can see this first thing here is the resolver, and the way this resolver is going to work is it's going to issue a get command against this path, API v1 products, and so it's going to get back product information, right? And it's going to issue that request against this upstream that you see was just created here, this product page upstream. So, and that's all we need for our resolver. Basically, the code that actually animates this resolver resides in the service itself. We're not writing that code ourselves. We're simply telling Glue Edge how to get that, how to exercise that service to get the information out. Well, then finally, what we need to do is we need to specify a schema that's associated with the information we're going to get back. And so that's what this is. We're not going to go through this in detail, but you can see, here's a query that we'll be exercising products for home with a pointer to how to resolve that. And then you can see there are all of these types that we're going to specify. So a product has an ID, it has a title, it has a description, and we can go, here's a review. It has a similar kind of structure here. So you can kind of see the different elements of the structure that we're going to be publishing out via our GraphQL interface. So what is that? One other point I want to highlight here before I move on to showing you the schema. So what we have right now is Glue Edge supports what's called local execution. So in other words, we need to be able to we want to be able to take a look at REST GraphQL schema, specify how those map to GraphQL, and handle that in our local cluster. What's coming in the next release that's going to be available at the end of next month, end of July, is the ability to also do what's called remote execution. So in other words, let's say you have a GraphQL schema that's already out there that you'd like to be able to leverage, in addition to these features. So you can bring all of those things together, both locally discovered schema as well as GraphQL schema that exists remotely. And you can manage all of that in a single graph, a single super graph, if you will. So that's coming very soon. We won't be showing that today, although it is in public betas of the product at this point. So what we do want to show you is this GraphQL API that we are going to specify that kind of lays out our schema and our queries. This is what it looks like. All right. So you can see we have a number of resolvers that are specified here. Okay, with kind of path information for how to get at that. So again, no real code here, just kind of specifying this declaratively. We can also see here is the schema that we're getting back here. And so this is what we're going to specify and kind of overlay this on this application network to get at the information that we want. So let's go ahead and we'll apply that. Okay. And then we're going to specify a virtual service that's going to allow us to route to that book info application. So this is a little simplified from before. We're not going to show the base REST service this time. We'll simply show here's the GraphQL service router, and here's the route to the Altair client. All right. So let's specify that virtual service. Okay. And then again, we're going to go to the Altair client to execute that. We actually probably shouldn't need to do this again because the URL should still be in the Altair client. But we do want to specify a different query. So this is the products for home query that you may recall seeing right here, right? That's going to delegate off to this particular service in book info, and so then it's going to extract just the information that we need here. Okay, so ID, title, description, and so forth, as well as digging into the reviews component. So for all of the products that are listed here, we're going to take a look at the reviews that have been published for those with information about the reviewer and the actual text of the reviews. So that's what this GraphQL query is going to do for us. Let's select that. Let's go to the Altair client. This URL is still good. We'll simply replace the query here with our new query. And when we hit send request, what you'll see is there's some issue with one of the backend services that actually causes this to happen. If you hit send request a couple of times, that'll actually go away, and you'll see the proper response right here. Okay, so this is what we get back. So you can see the format of the response matches the format of the query, and we have the information for this particular book info product. Okay, and again, you can see here's the text of the reviews that we've pulled in as well. All right, so that is good stuff, and that's the that's the end of this example, where we basically specified our own GraphQL schema and resolvers against a network of microservices on the back end. Now, the next thing we're going to do is to show you how we can use with this GraphQL endpoint. Now, we're going to show you how you can secure that endpoint using out-of-the-box features of GluEdge. And so that's going to be our fourth exercise. So let's hit the check button. Everything should be good. And then we will go to our security lab here. All right, so we're going to give you a couple of, there are literally many ways that you can do authentication and authorization with GluEdge. If you take a look at the documentation, here's the list of the kinds of things you can do. So we're not going to go through all of the security features exhaustively, but we do want to show you a couple of representative ones that match what people often want to do with these kinds of interfaces. So let's go back. Let's go back here, and we're going to start off with just doing some basic API key authentication. Okay, so to do that, we're going to specify an API key. We're going to put that in a Kubernetes secret. All right, pretty simple. If you take a look at that secret, right, what you'll see is there's now some metadata associated with that. There's also the base 64 encoded version of the API key itself, and you can also see we have some metadata attached to this, which is useful. So, for example, we have a label here that says the team name is Glue, and so we're going to use that to basically say what are the valid API keys that we want to be able to use with this application. So you see, we've built another custom resource here, and it's something called an auth config. And this auth config is going to be based on API key authentication. And it's going to look for the name API key, which you can see right here. And it's going to say, hey, any API key that has this label selector or that has this label team Glue, that's all of those are valid API keys for this application. So what we're going to do is we're going to apply this auth config, and again, just like everything else in GluEdge, it's a this is a Kubernetes custom resource, first class citizen in your kube environment. You can store it in YAML form in your Git repo, manage it with Flux and Argo and whatever kinds of GitOps tools you use, and you'll be in good shape. All right. So what we're going to do then is to apply this auth config, we don't have to rewrite our virtual service. We're simply going to patch it to add this new option called xauth. It's going to point to this auth config object that we just created. All right, so let's apply that. Okay, and so now what you can see is if you take a look at the virtual service that we have created, right, you can see that we've extended what we had before to add this option right here, this xauth option. So everything else is identical to what it was before, but this xauth option is what's new that will enforce the API key policy that we just specified. Okay, so now I want you to notice, right, we haven't bounced the proxy, right? Proxy's still sitting there, but what we have done, we've served up some new configuration to it. Now let's see, will this take effect immediately? So we're going to go back to the Altair UI that we were using before. We're going to use exactly the same query that we used before. Okay. Now, what do you expect to happen, right? Now that we've added this policy, what you expect to happen is you're going to get a different response. You're not going to get the answer here, right? You're going to get back a 401 unauthorized request or response code, and you can see that's exactly what happened, right? So we got an HTTP failure, right? We got a 401. Hey, this operation is unauthorized. You got to fix that. So how do we fix it? Well, very simply, in this case, what we're going to do is we are going to specify the API key using the features of the Altair client itself. So go over here and copy the actual value of the key, and then go to this little starburst icon here that says set headers. And we're going to, for set headers, we're going to specify the header API key, and then we're going to give it this value. All right. We're going to save that out. And when we send this request, now what do you expect to happen? Now everything is just like it was before. That's pretty cool, pretty dynamic, pretty nice stuff. Okay, so that's an example of how you can integrate a security policy with your GraphQL server, all in the same gateway component. Now we're just going to show you one other security feature as well. This one will be really quick. This is a security feature called data loss prevention. If you want to learn more about it, it's all described here. So what data loss prevention allows you to do is to if you have sensitive information that's being served out of your application, potentially into the logs or in a user interface, you may want to mask some of that, right? You don't want to publish out someone's social security number or Visa card number or something like that. You want to be able to mask that. And so this gives you a facility for doing that. Again, completely independent of GraphQL. This is just another feature of the API Gateway. And so what we're going to do here is we're going to, again, patch our virtual service to mask. You can see, let's just assume that this reviewer information is sensitive, right? Sensitive information. So what we want to do, we don't want to put out the name, PII. We don't want to put out the name of the reviewers out there. So we're going to mask that. We're going to mask that. And the way we're going to do it is we're going to mask 50% of the value with a star character, basically anything that matches this regex. So very, very simple example, not terribly realistic, but it'll do for our purposes. So let's go in here and let's modify our virtual service to have this this DLP data loss prevention option. If you want to go see the full manifest of the virtual service, there it is. There you can see. Yep, here's the DLP stanza that we added. And so now, what do you think is going to happen? Right? You should be ready for this by now. If we go back to our client and we hit this button, right, this policy has been applied dynamically. And so what you expect is immediately on the next request, right? Look at that. So the sensitive reviewer information is masked just like we specified. So pretty nice way to be able to integrate onboard your same proxy where the GraphQL interfaces are being published. You also get all of these other API gateway capabilities, rate limiting, security, etc., transformations. You get those that ride along for free, and that's pretty powerful. Okay, assuming you're all still with me at this point, we are at the end of exercise 4 at this point, and we're going to hit the check button and move forward to exercise 5. All right, I see some good questions there. Ravi, thank you for those questions. Adam, of course, is nailing the responses, and that is good stuff. So this is going to be, in some respects, the most complex example we do, and that's because we're going to talk about schema stitching. So one of the things that you find when you are scaling up a GraphQL deployment, actually, let's go ahead and apply this first step first, because this takes a minute to roll out. So let's go ahead and roll this out, and then I'll talk about the motivation for this a bit. So let's go ahead and apply that, and let's go ahead and do this next one as well to manage the rollout and the labeling of the services. So here's the issue. The issue is you work in an environment, in an organization that has multiple development teams. Each of those development teams have a suite of applications that they serve. And maybe, let's say some of them have published GraphQL interfaces, some of them haven't. Some of them are REST, some of them are gRPC. You don't really know. But what you'd like to do is, as you begin to work with these teams, you find where, like clients are coming in and they want to hit your service, and they want to hit the other team's service, and then they want to hit the third team service. And what you'd like to be able to do is to make that more efficient by fronting this suite of applications across multiple teams with a GraphQL interface. And so the way that you do that, you need to be able to somehow stitch those schemas together, right? Perhaps even specifying some glue components so that, oh yeah, the user ID over here matches the user ID that this service requires, or the user ID that that other service requires. And so you can use this kind of connective data, connective tissue to bind these applications together into a unified super graph that really opens up a lot of power in terms of giving your clients what they want, as well as reducing the load on your server infrastructure and making that a lot more efficient. So that's what we're going to explore in this fifth exercise, is the notion of GraphQL schema stitching. Okay, so we're still waiting on this to come out. So what you're going to see here as we go through, you'll notice that we have three services here. There's a user service, a product service, and a review service. So this is new set of services here. One of the reasons we introduced a new set of services here is because these are gRPC services, right? So we've been talking about open API, or even services that don't have an interface specified. This is actually going to show you gRPC services, right? So again, another interface type that you can integrate seamlessly into your GraphQL queries with GlueEdge. And so then we're going to take the schema. We're going to discover the schema on each of these three services. Think of it like it's some e-commerce application, right? We have users who buy products, and then they leave reviews on those products, right? So it's Amazon. And so we have these three services, these three microservices that support users, products, and reviews. What we want to be able to do is discover the existing gRPC schema, and then be able to stitch those schemas together so that we have a unified super graph across all three. So if we take a look at this, you can see, ignore the first two, that's from our previous exercises. Here are the three that are relevant for this exercise, right? We got users, reviews, and products. These were all just discovered from these gRPC services that we deployed into the environment. So the GlueEdge discovery component has already run, discovered that, converted those into GraphQL APIs. And so, we can actually drill into this and take a look at the information. Now, what we're going to do to motivate this exercise, let's assume that our user service publishes these 4 bits of information. So there is a username, right, which is an ID, 37, and then there's a first name and a last name, so Adam Saya, and then country code as well. And there's some queries that are associated with that as well. Again, this was all discovered from the gRPC service. But then these other services, let's say the product service and the review service, they also have review information, right? So the product information, right, has users who have users have bought particular products, and so they know about user IDs as well, but they only have the ID, right? They don't have the, and so let's say we'd like to have more complete information. I'd like to know not just, it's user ID 47. I'd like to know it's Adam Saya. So let's say I'd like to stitch together these two schemas to provide that extra information in my query graph. Similarly, we're going to do the same thing with the review service. So you can see each review has an author, okay, and you know, there's an ID associated with that. But what we'd like to do again is to stitch that into something where we can actually see the full name of the user who authored that review. Okay, hopefully that's clear. So to do that, we're going to build a new. So okay, keep in mind what happened here. The first thing we did, we installed these services. We had function discovery turned on, and so 3 GraphQL APIs were discovered automatically for us. Okay, so that's really cool. Nothing we had to do there. All right, but now what we want to do is we want to build a stitched schema that takes all the elements of these other graphs and puts them together into a single coherent super graph. And so we're going to do that by building a 4th GraphQL API abstraction that we're going to call Stitch GQL. And we're going to specify what's called the type merge here that's going to basically go in, without going into all the details, it's going to say, hey, I want to use this username to stitch together the information from the user graph, so that the product graph can extract user information from that, and so the reviews graph can extract information from that as well. That's the basic idea. And again, if you want more information, there's definitely documentation out there about schema stitching that you can review and build your own examples. Okay, so let's go ahead and we'll apply this new GraphQL API object that specifies how we want to stitch these schema together. All right. And now we're going to also update our virtual service. The only update we need to make, it's not a very big update, but rather than going to, we're simply going to specify that we're going to use this stitch schema as the basis for our GraphQL API. Okay. So let's go and we'll apply that. All right. And now that we have applied that, let's go back and let's actually run a new query in Altair and see how that works. In fact, we're gonna have multiple operations here just to make it interesting. If you get a blank screen like this, hit this little refresh icon up here on the top right. That should, yep, there we go. There's everything. So, all right, so we're going to take out this old query. We're going to supply a new query. And notice this query has multiple components, right? We've got just the base. We're going to query the base user schema. We're going to query users by country. We're also going to, now this is where it gets interesting from a stitching standpoint. These last 2 queries here, first we're going to get reviews for product. Now notice what we're doing here is so we're going to get the reviews with the content of the review and the rating, but we're also going to dig into the author information and grab out of that schema not just the username, but also the first and last name of the review author. Same thing for products here, right? We're going to go in, and for the seller of these products, we're going to get not just like a user ID, we're going to get the first name and last name. So we're going to use this stitched schema in order to get this information. So let's send this request out, and let's see what we have here. Sometimes you have to do this one more than once. It looks like the get reviews for product is being okay. All right, now everything is here. If you get a failure, again, some issue, these are not production ready services on the back end. So, but you can see here, right? Here's our get user query that works like expected. Get user by country, that works like expected. Again, nothing special there. That's just using the discovered schema from the gRPC service, from a single gRPC service. But now look at this. Get reviews for product. We not only get the review content, we also get the detailed author information for each one of those reviews. And so again, a single coherent graph query produces all of these results that seamlessly from across multiple REST services. So pretty good stuff, if you ask me. All right. So we have done all of this now. And so this is actually the end of exercise 5. And I don't see any questions that haven't been answered. So I'm going to hit the check button here, and we're going to go to a very quick exercise. This is the final exercise, which is the GraphQL UI exercise. So one of the things you will notice in everything that we have done here, we have emphasized a configuration as code, a declarative configuration model for specifying these objects, and that's very much by design, because that's how most of our customers want to use this technology. However, for development purposes, for kind of playing around, understanding your graphs, that sort of thing, it is nice to have a UI as well. And so GluEdge provides an administrative or a UI in the administrative interface that you can use to get access to these graphs and run queries as well. So let's take a look at that. So hit the start button, and that's going to drop us into here. Looks like the interface is a little slow coming up. Again, just hit the refresh button if you're seeing a blank screen like I am. You hit the refresh button. Yeah, it looks like that's going to work now, probably. All right, here we go. So so this is just the straight GluEdge administrative interface, right? There's all kinds of interesting information in here you can use to understand what's going on in your environment. And specifically, we've added a set of facilities here around GraphQL. So you can see that under this APIs tab here. If you look at that and then you drill down into, let's drill down into this one for book info GraphQL. You can see there's one of the queries we dealt with before. Here's some of the types that are there, that sort of thing. We can go in here and explore that further and actually get our own client interface here, right? So let's do this. Let's get this to work. So let's get our URL here. So go back to the terminal, execute this command, and then copy that URL. Go back to the GluEdge interface and actually specify here. So show the URL bar, and there you go. So there you can see that's our URL that is going to allow us to get into our instruct environment. And then we also need to specify a query. So this is the same query we used before in the book info example. So let's go ahead and specify that here. Whoops, I hit it twice. That's not what I meant to do. Only need one of those. And we will run that, and you can see, right? So right here in the GluEdge UI, we can get information here. If we want to go to the Explorer interface, maybe you want to see what it looks like with different set of characteristics, like, oh, this description HTML, that's pretty verbose. Let me get rid of that. Maybe I don't want to send the reviewer information through because that's sensitive information. So let's remove that. You can see as we change this, it changes the query on the fly. And if we run this, you can see then we get back the information without the things that we turn the checkboxes off there for. Okay, so that's just a quick tour of the GluEdge UI, and actually we've made it to the end of our session.
Wow, that's a lot of material. And I want to congratulate you on making it to this point in our double workshop covering both GluEdge and its GraphQL extension. Since this material was recorded, there have been some other exciting developments around Solo's emerging GraphQL platform. It is now available not only in GluEdge, but also in our Istio-based service mesh platform called GlueMesh. If you're already using Istio or perhaps considering a move in that direction, I encourage you to visit our website at solo.io to learn more about GlueMesh and its GraphQL integration. And while you're at solo.io, check out our blogs, our events page, and our detailed product information. You can register there for live consultations about your own API gateway and service mesh requirements, and you can request trial licenses for our enterprise products. There's also a Solo community Slack channel available at solo-io.slack.com,
we invite you to join the discussion there as well. Thank you for being with us today. Enjoy the Container Days conference, and I hope to speak with you all again soon.